Okay, so it looks like we are indeed live. How you doing, Amos?
Not too bad. Yeah, kind of trying to stay on top of things a little bit here. It's been a busy week. How about you?
I'm all right. It's been a little bit of a frustrating day, and as you can probably hear, I seem to be losing my voice a little bit. I've been on a lot of calls and then streaming, of course, for Pipe the other night. Not that I talked very much doing that. Raf does most of that, but I've been just on like all day long calls
Yeah,
for a couple of the last couple of days. Yeah, just kind of working on some code with other people. So,
nice.
but
Yeah,
but
that'll
yeah, it
be
really is. It really is doing a number on my voice. And then much of the programming that I was doing today was very, very annoying. So it
yeah.
happens sometimes. That goes with the territory. But
Yeah.
we got less done than I would have liked to have. It's all right though. We'll get more done tomorrow, and I will once again probably be on an all day call. So hopefully my voice will hold up. But yeah,
Yeah, no doubt. Yeah, we're headed out tomorrow, so and I still got a bunch of stuff I got to pull together. So I probably have a little bit less time this evening. It'd be good to keep it a bit shorter.
okay, yeah, that's fine. I think we talked about that briefly before. We can go to 10:30.
Cool.
That will be fine. Okay, so let's see. Do you have Racket? I am looking at what appears to be a completely blank black desktop background with no name. Is this what I'm supposed to be seeing? You changed your desktop background to black.
Yeah. I was actually gonna check it out to see what other options are there, but I didn't run out of time. So
Okay, well, hopefully it will reduce the lag a little bit. I think part of it was just that your upstream is low enough that even with compression, sending uh, sending a lot of image data seems to slow it
good.
down some. So
Yeah,
yeah, this will probably help with that. I might choose something other than black if I were you, but it's fine. So I don't know. Do you have Racket open?
I believe I do. Yeah,
Okay. So one of the
and I just
things. Hmm.
well, I haven't done anything since we last met. Once things slow down a little bit, I'll hope to be able to mess around with stuff a little bit in between. But I'm like just I'm gonna have to like remember what the hell is going on.
Yeah. Um, I'm actually going to unmute for a moment. Can you just say something? I want to verify that your voice is coming through properly. I'm
Yeah,
actually going
okay,
to
sure.
unmute for a
I'm
moment. Can you just say something? I
talking
want to verify that your
and I'm
your voice is
testing
coming
one,
through
two,
properly.
three.
I'm
Yeah,
actually going
okay,
to
sure.
unmute for a
I'm
moment. Can you just say something? I
talking.
want to verify
I
that
don't have
your
any
voice is
headset
coming
in or
through.
anything like
Yeah,
that.
yeah,
Just using
that's really more than enough. Thank you. I'm sorry.
or anything like
Yeah,
that.
yeah,
Just using
that's really more than enough. Thank you. I'm sorry.
or anything like that.
Yeah, all right. I'm a little bit concerned that I think there may be coming through double. It's really hard for me to check, actually. So I don't know. I think there may be a little bit of an echo, but it's a little hard for me to tell. We're very new to this, so anybody watching, I don't think anybody's watching the stream right now, but anybody coming to this later on, let's hope that the audio is okay and is not completely doubled, etc. It
Mhm.
seemed to work last time, so hopefully it's working properly this time.
Okay. Yeah.
Okay. So you have Racket. Now you also seem to have Racket in dark mode. So this is going to get pretty terrifying on the eyes eventually. But go ahead and do what you want to do. This would probably not be my choice, but we may want to like open this. We may want to expand this, like full screen it. Yeah, there we go. And
Yeah, didn't
I guess something that I am wondering about a little bit is what I am wondering about a little bit is we saved a file last time. And of
Yeah.
course, you saved it to Lisa's iCloud. We may just have to start over with that, which is fine. I think it may be a little hard to find at this point.
Yeah, I was trying, and it was Racket, wasn't it? It wasn't because I went and looked for, I think called Session, and it does seem like I have access to the main drive, but from here or whatever, at least to some stuff, but I couldn't find it.
Okay. Well, that's fine. And one of the reasons that we did like do that work of getting you set up with you on your user account is that you now have a nice place to save your files to, which is your home
Totally.
directory. So that's what we'll do. And in fact, you should probably make a subdirectory in there, and we'll walk you through a little bit of that. Mostly, we would like to get to coding and not worry too much about the details of computer systems. But, we're going to have to do some stuff with this. So one thing we did is we installed iTerm. And you may want
Yep.
to you may want to open up iTerm at this point.
Uh,
There's a little bit of lag
yeah, I got to turn open now. And it still is.
here. Okay, there it is. So you probably want to at some point make some sort of a little crib sheet just of little things. We
Yeah.
won't worry about it too much right now, but so one of the first things, you remember we looked briefly at this. This is the terminal, and you can do some nice things from here. And one of the things you can do is you can type in PWD.
Oh, you're gonna do.
And that tells you where you are in the file system. So note that the file system starts with a slash, right? Slash is the root of the file system where everything begins.
Okay.
And then there's a users directory that contains user directories. And then there's Amos, which is your user directory. So that's where you are, is in yours. And so that's a good thing to know. You probably don't want to save things directly into this directory. You probably want to make a subdirectory right now to save things
Okay.
into. And so maybe you could make a directory. You could just name it code, for instance, right?
Yep.
But just something so that you're not just littering files about the top level of the directory. So the way you
And
make a directory, an empty directory, is to just type mkdir space and then the name of the directory you want to make.
that's it.
That's it. And if you do an ls now, which lists the contents of the directory that you're in, you can see there's quite a bit of stuff that kind of came with it, standard Mac stuff,
And there's code.
and there's code.
Cool.
So you now have that directory, and you can minimize this terminal if you'd like at the moment, and we can go back to Racket and start taking a look at stuff. So I think we should recap what we were doing last week because a lot of this stuff, it's pretty important actually to get the fundamentals of it right from the beginning. And yeah, it's been a week, and I don't know that you've had a chance to look at it since then. So
I'm not. I know. I'm just trying to remember something important.
well, let's talk about the stuff that we did, and the important stuff about it. So this is the REPL, right, where your prompt is, and it stands, for read, eval, print, loop. And we're primarily concerned with the eval part of that right now. The read part is pretty interesting too, but maybe we'll put off talking. Yeah, I mean, in some sense, the read and the eval are really tightly bound together.
Mhm.
But if you type a 6, for instance, right now, you remember this is probably, I think, about where we started, right?
Yeah.
This is one thing about Racket, right, because we're not working at that. You need to tell it what language to use. So if you go and in the top pane on the first line, you just type sharp LANG with no spaces in it. No, I'm sorry, sharp, the sign sharp.
What's
Like,
the sign?
like a hash mark. Right, 2 vertical bars crossed by 2 horizontal bars. Like a sharp in musical notation.
2 vertical bars cross.
It is
Oh,
it is like shift 3. There you go. It comes up a lot in programming. Sharps are used all over the place. So LANG, and then on that same line, just put like space Racket.
oh, yeah.
Right. So this is necessary. You need to tell Racket what language you are using before you can put things into the REPL. And you'll have to hit run now, I believe, just so that takes.
I don't remember doing this last time. I was already in it.
I think we did it, or like maybe we had done it actually when we did your first setup of Racket, right? Which was still under Elise's account, and like it's sort of a hanger on from there. But you're a new user, right? So it's not using some of the setup that you did before because that was setup that was specific to the other user, right? You
Yep.
could have 10 users on a system. They don't all want the same setup, so they're not all going to save like things like preferences to the same places.
Sure.
Anyway, so now this works. You type in a
Yeah.
6, you get a 6. And if you type in pi, right, you get pi. And so we say that the name pi is bound to that value,
Hmm.
which is pretty useful. But if you type in pig, like we did last time, right?
Doesn't know.
Right, it doesn't know. You have not, that name has not been bound to a value in this environment. So do you remember how to, at the top level, at sort of the, I'm going to use the word global here, but at the global level, do you recall how to bind a value to a name?
Oh man. Give me a second. Let. There's something let, yeah?
Let does it locally, right? Let does it. That is what we were talking about right at the end. And let creates a local binding, but we want to make a binding that's like completely visible right now. We're going to call it global, even though I don't know if that's quite the right word in this context, but it's basically globally visible within the
Uh-huh.
program. So you use define to do that, right?
Define. Okay.
And okay, so you need to put a parenthesis at the beginning of it. And maybe we did this a little out of order. Maybe we should have looked actually at functions first. So let's do that. Before we do this up in the top pane, if you go down into the bottom pane, right? Do you remember how to add, like, say you want to add 6 and 7, how do you do that?
Is it just uh, space there?
Okay.
No.
Now what's, okay. So,
It needs, oh, yeah, right. Okay, hold on. There's a plus in there somewhere. Can't remember the order of things.
so this is, so we're kind of talking about the rules of what happens when you evaluate things at the REPL, right? And so one rule is that a number evaluates to itself. There's another very important special rule, and that is, yep, that is correct. And what that rule is, and it's kind of important to remember this and think about it in this way, okay? Which is that open parentheses are special. They mean something special, and there's a rule for reading them. And the rule for reading them is that you look at the thing directly after that open parenthesis, and you
Hmm.
evaluate that thing, and then you try to apply that as a procedure to the remainder of the things within the parentheses. Okay.
Okay, yeah.
And it turns out that when you evaluate plus, if we just type plus in, for instance, at the REPL,
Without the parentheses?
yeah, just plus by itself, right? It evaluates to a procedure.
Okay.
So a procedure itself, by the way, also evaluates to itself, just like 6 evaluates to itself.
Yeah.
So you can have, so that's why it's kind of important to think about this in the way that I was talking about, right? That,
Hmm.
and to be very literal about it, which is kind of something we haven't talked about too much, but that we will talk about in the future, that computers are very literal. And that means that when you program them, in some cases, you yourself have to be extremely literal, right?
Right.
You kind of try to bring preconceptions to it sometimes. And then those preconceptions turn out, the computer doesn't have those. And so they lead you astray. So we want to be very, very precise about this and very literal about it, that like what's, that when you see the open paren, it means that the thing after that open paren is going to be evaluated, and then it's going to try to apply that to the rest of the arguments in the way that a procedure is applied. There are some
Hmm.
other things that can be applied to arguments too. Procedures aren't the only thing. Now, define happens to be one of those other things, and define is not a procedure. At least I'm pretty sure it's not in Racket. Define is a special form, but it operates in the same way. And so if we want to bind a value to pig, right? We go up there, yep, into the top. And I'm having a little bit of trouble reading it. My vision's not very good, but did you begin that with a parenthesis?
No.
So that's kind of what I'm talking about here, right? There is a special rule. Define by itself isn't going to do anything, right? When you want to apply something to arguments, you need to put the open parenthesis in front of it, right? That's how it works. There's some other ways of doing it, but that's generally how it works. So yeah, define pig 42. Yeah, this is hard for me to read with this color scheme.
Okay.
My vision is a little bit. It's all right. We'll keep going, but don't necessarily expect me to always be able to like see what you're doing.
Yeah.
So you do have to hit run again, though, right?
Oh yeah. Right.
If you see that yellow warning right at the bottom, that's what it's telling you.
Oh, and that clear. Yeah, right. That clears all that. Okay.
Yeah.
Cool.
So now you
How do I
got that.
change the color on this thing?
That I am unsure of, and it may be an operating system level thing, and I don't think we should worry too much about it right now. right? There's
Okay.
something
Yeah.
to figure out. We'll just kind of muddle our way through. But I am having a hard time, like telling, like those parens especially are difficult for me to read. My vision's not perfect, so. Um,
Yeah.
but yeah, so this is sort of we kind of have jumped ahead a little bit to some of this, but so it's important to understand a little bit about what's going on with these symbols, right? And do you remember we talked a little bit about the use mention distinction?
Use mention. It does sound familiar, but I'm not bringing it up to.
So, for instance, if I say like cats are four-legged animals,
Hmm.
that's one use of the word cats. There's another use of the word cats, which is I can say cats has four letters in it, right?
Hmm.
And so
As a word.
in one of them I am using cats, right? To refer to cats. That's kind of its use, right? That's why the
Hmm.
word exists so that I can refer to something. I use it for that. But in the other sense, I am mentioning the word itself, right?
Hmm.
And it's an important distinction to bear in mind. And it's one that you really, really want to be very precise about in terms of thinking about what it is that you're talking about. So when you type a symbol, when you type a 6 in, for instance, at the REPL, that evaluates to itself.
Hmm.
But when you type a symbol in, it doesn't evaluate to the symbol, it evaluates to the thing that the symbol is bound to, that the symbol refers to, right? So that's the use part of it. When you type pig in, for instance, right?
Yeah.
You get 42. But the symbol pig is itself a thing, right?
Hmm.
And if you want to refer to it, you can pass it to quote, which is another special form. So try
Okay.
passing pig to quote. Try applying quote to pig, and it's just spelled out Quote.
Oh, gotcha.
Yeah, that's right. And you can see that there's a
What's
shorthand
that?
for this, which is how it printed it out. If you use a single quote in front of the symbol, that is equivalent to typing what you just did with applying the quote to it, and is usually what you do. It's usually much easier to do that, right? Especially for
Yeah.
symbol. So try quoting pig using the shorthand form. There you go. And
Yeah.
you can also quote the plus sign, right? Give that a try.
Mm.
Yeah. So one thing that we didn't talk about this last time. Um, One thing that's
I,
important. I'm sorry.
we just gotten a single quote, I think. Or, well, you just call it quote.
Well, yeah. I mean, we went on to other things, but there's something that we didn't talk about last time that I'm just going to mention here. And this may not seem that weird to you. It probably seems pretty weird to somebody who hasn't programmed in Scheme before, because this is not how most languages work. So in most languages, plus is really built into the language as an operator, right? Like a plus sign just kind of either it always means add two numbers together, or it can have some. But the thing itself is really fixed and static. This is not actually true in Scheme, right? So, for instance, we've also seen times, right? So try doing plus 2 3, right? Add 2 to 3. Okay, and then can you multiply 2 by 3? Okay. Now we're going to do something that you should never ever actually do in real life, right? But I just want to do it to make a point. Try defining plus to be times, right? Don't do it up in the top. Well, you don't want it up in the top. Just do it at the REPL. Because stuff up in the top like tends to hang around.
Mm. So do the plus.
That's right. Yeah. So, okay. Yeah, it's not liking the fact that you typed that stuff in the top and didn't remove it.
This one here,
Yeah.
line 5.
Yeah. Because it's a syntax error as well. So that's fine. But you did that. Now, try adding 2 to 3 again. Hmm. So
Uh-huh.
what did we just do here? Like, you can see why you should probably never do this, right? This could be very, very confusing. But it's just kind of important to recognize that, like, addition here and scheme here. So there is the add procedure itself, and that's what adds numbers, right? The plus sign is not the procedure. The plus sign is just a symbol that is bound to that procedure. You can rebind it to something else. It's not a very good idea, right?
Right.
But you
Got
can
it.
make it
Because
do
it's a basic enough thing that you want to use it as its thing. Like if you, right?
Yeah, it's very confusing if you use a plus sign and you get multiplication, right?
Yeah.
Like that it's very, very hard to think of a case in which you would actually want to do this. But you can, right? It's very flexible. And this isn't really true of most languages, right? And most languages, plus may be able to take on more than one meaning in a variety of different ways. There's stuff called operator overloading. There's a number of things. But you usually can't just completely redefine what the plus sign means in most languages.
Hmm.
Okay. But the other thing is it makes the use mention distinction very, very clear here, right?
Yeah.
Like the plus symbol does not inherently have anything to do with addition. We happen to bind it to a procedure that does. So that procedure that adds things, there's no way for us to really change it. It's built into the language, right? We can't really get it its guts. It will always add numbers. But the symbol we bind to it is just a different thing. And you could bind your own symbol to it, to the procedure, right?
Yeah.
And you could use that in place of plus if you wanted to. And that wouldn't necessarily be quite as terrible as rebinding plus to equal multiplication. However, because we've done that and we don't want it to continue to be the case, one of the reasons we did it down in the REPL instead of doing it up top is that you can now hit the run button.
Huh. Because it's not up top, it'll just bring it back to, because it erases everything.
Yeah, when you hit run, it gives you a totally fresh new environment.
Yeah.
But then
right.
it runs all of the code in the top pane, right?
Yeah.
But anything you've typed at the REPL gets lost, right?
Yeah.
And that's good.
Okay.
We wanted to lose what you typed at the REPL because now if you try adding 2 to 3.
Yeah. But was there a way to redefine? I could have redefined down below as well, right? But rather than just erasing it all away.
You could have, although how would you have gotten the procedure back?
I was just going to define plus as plus.
No, because we'd already defined plus to be times. So then if, what is it that you were going to define plus to be? So actually we should talk about this a little bit more because maybe it's not completely clear.
Yeah, I see what you mean. If you're defining plus as plus, then it says, yeah, plus is plus as what we know as times. I mean, the procedure would be the multiplication.
Right. You can bind it to the symbol, to what the symbol plus is bound to. But that's literally a no operation. If you define something to be what it itself is bound to, right, then nothing happens. That's just tautologically true, right? You had kind of lost access to the actual procedure giving you plus. Now, there are other ways to get access to that procedure. And especially because you'd already evaluated at the REPL, pretty sure there's a way to just get access to all of the results that you've printed to the REPL before. I'd have to look it up because I don't know Racket well enough to know what it is. But there wouldn't have been a super easy way to do that. Whereas there is a really super easy way to just hit run and everything's back to normal. And it's kind of important to remember that, right? Like, if you want things to go back to a sane state, and they're not in a sane state because of something you've typed at the REPL, then hitting run will bring you back to a sane state. Now, if they're in a state that isn't very sane because of something you have in the top pane, that's not going to be true. Okay.
Right.
Because it will run everything in the top pane. So yeah, that's some of the stuff that we talked about. Know, for instance, that if you type in double quotes, try typing in double quotes, PI double quotes. Right. So this is a string. And we haven't talked much about strings, but strings represent actual text. And note that the string pi is not the symbol pi. They're two very different things, right? And strings are like numbers. They evaluate to themselves. When you put a string into the REPL, you get the string back.
Right? And that the string is signified by the open quotes, closed quotes?
Yes, by the double quotes. That indicates strings.
Quotes.
So we talked a little bit about numbers. We talked a little bit, for instance, about how if you add like 0.2 to 0.1, you don't get exactly what you might expect,
Hmm.
Do you recall that?
Yeah, I remember getting some weird where something was supposed. Was that what it was? And it didn't.
Well, try it again. Try adding point 0.2 to point 0.1.
Oh yeah.
Right. So these are point 0.2 and point 0.1 are, in this case, they're floating point values is what we call them. And we're not going to talk too much about what that means right now. That's not the only way to represent decimal numbers. And in fact, it's not the only way that Scheme has of representing decimal numbers. But, or at least that Racket has, is what I should say. But it is what you get by default when you type, a point 0.2 in at the REPL, you get a floating point number. Floating point math is inexact, right? You cannot always count on floating point mathematics to give you the results you want. But you'll note something. You can type like 2 over 10, for instance, at the REPL, right? 2/10. And I think you'd better not put spaces in it. I'm not sure. But
Oh, literally do that. Not
literally
actually.
type 2. Well, yeah, you don't put it in parens, though, right? What does the paren mean?
Means like evaluate after the next. Yeah.
Evaluate it and then try to run it as if it were a procedure and apply it to the rest of the things in here. So if you type in, yeah, let me give you an example of what I mean and what was about to happen here. Try typing in pig in parentheses, for instance. Right? You're going to get an error here, right? Because what it's doing is it's trying to apply pig as it were a procedure and apply it to, now, there's nothing else in these parens, so it's trying to treat it as a procedure that takes no arguments, right?
Huh.
Because pig is bound to 42. So try typing 42 in parens.
It'd be 42, right? No.
No, it's doing exactly the same thing as above. This is actually literally exactly what happened when you did pig. Remember, the rule says evaluate the first thing after the parenthesis and then treat what it evaluates to as if it were a procedure. So pig evaluates to 42, tries to treat it as a procedure. It can't. 42 is not a procedure, right?
Yeah.
If you put 42 in the parentheses, and I'm sorry if I seem like I'm belaboring the point a little bit, but this is actually a really, really hugely important point. Like, what's actually happening when you type that paren in, what that means. And it'll get very, very confusing later on. If you don't really take it very literally.
Okay, so if I do 210, because I was thinking 210 was like a procedure involving division. You know what I mean?
It's not. 2 out of 10 is literal syntax for this. Now, the divide sign is, that slash is. You can also put in slash 2 over 10. And,
whoops.
Yeah.
What was it? We'll do it like this.
And you'll get the same result back. You're dividing 2 by 10. There's a slight difference in terms of what we did, though. When you type 2 over 10 at the REPL, you are literally typing a number, a rational number, okay? And it is the literal syntax for that. When you type in the slash, the 2 and the 10, you are applying division to the 2 and the 10.
Yep. That makes sense. So, but the first version without the procedure, without the of division, it's not condensing it. What am I trying to say? Simplifying it down to the lowest common denominator.
Yeah, it is reducing it to simplest terms. Yep.
Yeah.
Now, what you can try doing is adding 2/10 to 1/10. So you see that this is an exact result, right? Because 3 over 10 can be represented exactly, right, as a rational number. Note that not all numbers can be represented exactly as rational numbers. And so there are numbers that you cannot exactly represent in your computer, right? And exactly what that means it's a pretty complicated subject, right? But let's note that once we get into the realm of floating point numbers, it's just important to understand that floating point arithmetic is not guaranteed to be exact, right?
So is that like the 0.2 plus 0.1 floating point decimals? That's just standard. That's how it's set up. I mean, I'm going to get that every time with those same number of zeros. If I do that
in Racket, that's true. in
Yeah.
another programming language, actually, it is possible that something else could happen depending on the programming language. But in general, actually, when you see that go wrong in programming languages, even that aren't Racket, it will probably still be exactly that result because it actually has to do with the nature of how your computer is doing this math.
Hmm.
So, this, like I said, this turns into an
Yeah.
extremely, extremely complicated topic, and it's not one that I want to get into a lot. It's just, and you shouldn't don't rely on it being like, oh, it's exactly going to be this 3 point, like
Yeah.
what that means is something extremely close to three, and just, or I'm sorry, extremely close to point three,
Yeah.
and like that's what you should be thinking is if I add point two to point one, I am going to get something that is very, 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 very close to point three, right?
Hmm.
But it is not guaranteed to be exactly that, and that's just how you need to think about floating point math.
Okay.
Whereas the math with rationals, assuming you can do math with rationals all day long, and it will always be exact because integer math is basically exact in computers. Like it gets complicated even there, to be perfectly honest with you,
Okay.
because integer types can have limits to how large they can be, and this varies quite a bit from programming language to programming language. But let's just say that unless your integer types are very large, right?
Hmm.
Then as long as you're dealing with like reasonably sized numbers as the numerator and the denominator of your rationals, everything there will be pretty exact. But even that has some complication to it, right? Numbers in computers are complicated because there are an infinite number of numbers,
Yeah. And it's
and
actually at them. It's not like a theoretical whatever. It's or what it, that's what it's calculating it, even though it's like, why do you have to think about it? It's obvious one of them, but it has to actually do it every time.
yeah, I mean, and the thing about it is that there's just a limit to how many numbers. I mean, look,
Yeah.
there not only are there an infinite number of numbers, there are an infinite number of numbers between 0 and 1, right?
Hmm.
But there are not an infinite number of ways your computer's memory can be configured, right?
Yeah.
So
Yeah.
therefore, it's very, very clear that, for instance, there's no way you can set your computer up so that it could represent every number between 0 and 1 exactly, right?
Mm.
It just can't be done. There
Yep.
aren't enough possible configurations to distinguish between them. And that's true no matter how much memory your system has, right?
Yeah.
So, that right there kind of demonstrates to you the impossibility of that.
Hmm.
And numbers are
Sure.
strange. And by the way, I have a cat. You can probably hear him, who gets very yowly sometimes at night.
That's
And
so funny. I thought it was our cat.
no,
I mean,
no,
not
that is my
cat.
cat. And there is unfortunately not too much I can do about it. When he gets like this, he's going to wander around. What he really wants is actually for me to go to a very specific place and pay attention to him right now in that place.
Hmm.
It's very weird. He wants to sit in the shower stall and he wants me to come say hi to him in there.
Yeah.
Okay. All right, cats. Yeah.
Yeah. I'm like, I'll leave that one alone.
Yep. He really, really likes it in there for some reason.
Yeah.
But he's been pretty yowly lately. Anyway, so yeah, so we looked some at numbers like this. We talked about this a little bit, and then yes, we looked at some other things. And really, what we looked at, the first thing we looked at was how do we actually like define procedures, right?
Lambda. All of a sudden it came. I'm trying to remember that word. Lambda, right?
Lambda. Yep. It's a Greek letter. If you look at okay, do you see the Dr. Racket logo anywhere? You've seen it, right? It's those two lines, those two curving away lines. It's
Yeah.
the icon, right? If you look at your taskbar for a second, you'll see it.
Yeah.
That is a stylized lambda, right? Lambda is a letter of the Greek alphabet.
Cool. Does not look like an L. That's okay.
No, it doesn't.
But I must say I was getting a little bit lost the difference between define and lambda.
Okay, so right, we should talk about this again because this is again very, very important.
Hmm.
So, do you recall the syntax for making a procedure using lambda?
No.
Okay. This is why it's kind of good to like have, yeah, we should definitely like save a file with some examples in it. So
Yeah.
maybe you might want to, but let's type it first at the REPL and then we can move it up into the upper pane. Okay. So if you open a paren here, right? Let's write square. We wrote square last time. So let's write square again, right? Let me actually pull my racket over so that I can just type stuff in and make sure, just to make sure for myself that everything's going well. My cat has clearly been editing my racket buffers. Okay. Okay. So I could probably just send this to you on Discord. We went over this, but if you don't recall it, maybe the easiest thing to do is just send this to you, and you can copy and paste it in.
It was like, nah, I'm not gonna be good.
Okay. Let's try putting that in, and let's talk about. Maybe we shouldn't do this actually. Like it does induce a lot of lag when you're switching programs. So, but yeah, there you
Yeah,
go.
I mean, decent. It's too bad to have you. I know it's kind of funky, but right. Okay. So it was kind of
So that's a procedure, right? That squares
yeah.
things. Now, do you remember what we said about the very special rule about parentheses? Can you use that lambda there, modify that line a little bit so that it squares 6? Can you think about how you would go about doing that? Square 6 using that lambda.
With it now defined, let me just,
It's not defined. We didn't define it anywhere, so you're going to have to retype out the lambda.
okay.
But you're going to have to do a little bit more to actually apply it to 6.
Okay, let's see. I'm going to need more parentheses. Let me just get the thing in here, and then I'll go back and put them in. Oh. Nope. Nope.
So let's think about this a little bit. Let's talk a little bit about what that lambda expression itself does. Okay. So we talked about this last time. We'll talk about it again. When you say lambda, right, you say I'm creating a procedure at this point.
Okay.
And then inside the parenthesis is basically a set of arguments that that procedure takes, right? It's a set of names for those arguments. So it indicates how many it takes. And you can see that this is going to take one argument, right? Because we're squaring something. When you're squaring a number, you square one thing. You apply it to one thing, right?
Yep.
When you add things together, it could be a number, like it's actually a variable number of things. But when you square something, you're just squaring one thing. So that's what that X is saying is this function is going to take one argument, and within the body of this function, that argument, whatever value I get passed as that argument, is going to be bound to this name. Okay. So when somebody applies this procedure to something, they're going to apply it to one thing, and in the body of the procedure, that thing is going to be bound to the name X. And then the last thing in the lambda is the actual body of the procedure. And so what'll happen is, with this lambda, is when it is applied to a procedure, the body of the procedure will be evaluated with X bound to the value that was passed. Does that make sense?
I think so.
Okay.
Yeah, it should put X instead of the multiplication.
I'm sorry. What?
It should put X instead of the multiplication.
Well,
Okay.
you don't have to. So let's think about this, okay? So we know that lambda evaluates to a procedure that can be applied to an argument, right? Okay. The procedure doesn't have a name at this point. We have not, bound it to any name in the environment. But it is a procedure that can be applied to an argument. How do you apply procedures to arguments?
Open parentheses,
Okay.
uh, put the procedure, and then put the argument.
Well, something that evaluates to the procedure, right?
Okay, yeah.
Right. What does the lambda expression evaluate to?
Uh, X. Is it?
No. I mean, when you type lambda x, when you type that procedure in, it tells you what it's evaluating to. What is it evaluating to?
Just square. What do you mean?
Well, it's evaluating to a procedure, right? The lambda expression.
Mm-hmm. Okay.
So how do you take something that evaluates to a procedure and apply it to an argument?
You open the parentheses,
That's right.
put the
And then the very next thing after the open parenthesis is what?
the thing that symbolizes the procedure or evaluate.
The
I
thing
mean,
that evaluates to
evaluates.
the procedure, right?
Yeah.
What does that lambda expression evaluate to?
The a square procedure.
It does. So how would you apply that lambda expression, which is going to require typing it out again at the moment? How would you apply it to an argument?
What is to?
This is what I was talking about before, by the way, about being very literal about things.
Mm-hmm.
The computer's very literal. So we have a rule here. And if you sort of like really think through the logic of what lambda evaluates to and what this rule does, then it will tell you what you have to do. Okay. So here's the thing, though. Let's be very, very literal about this. What's the rule for an open parenthesis?
That it, the next thing immediately after it,
It evaluates that.
it's evaluated. Yeah.
And then it applies it to what?
Whatever comes after.
Whatever
in
comes
those
after it. In the
in
parenthesis.
those before the
So
parentheses.
I am just going to I'm gonna step in here and kind of give you a little, tell you basically how to type this, but I want to come back to what we've been doing here to show you what I've been kind of trying to get at here. So put another open parens. Start off with 2 opening parens, okay? Start this line. Just add one more opening paren to the beginning of the line. Yep. And then go and close the entire lambda expression after this times xx. Note that when we had it on the top line, right, there's double parens after that. Okay. And now take out, so yeah, get rid of that whole form and replace it with just a 6. And then make sure that your parens are closed.
I mean, the 6 is outside any parens.
Well, it's not outside of the outermost parens.
No, because it's double and this one.
We'll count them up from the left. How many parens have you opened till this point?
Oh, wait. Because that goes to, yeah, okay. I see what you mean. Yep.
You got one more. And now hit return.
Gotcha.
So let's talk about what happened here and why this works. And this is kind of what I was saying about being very, very, very literal in terms of these rules, right?
Mm-hmm.
So plus is a symbol that evaluates to a procedure that adds things, right?
Mm-hmm.
So when we want to apply it to 2 and 3, and note that you can apply plus to a single argument. We saw that before, right? So try doing plus 2. Just apply the procedure plus to the number 2. Okay.
Yeah.
So you see this rule in action here. You have an open paren. Immediately after the open paren, you have something that gets evaluated and that evaluates to something that is a procedure, basically, right?
Mm-hmm.
And then that procedure is applied to all of the arguments before the final closing paren, right?
Yeah.
So if you look at what we did here with this lambda of x times xx, if you kind of look at this at the lambda expression, right?
Mm-hmm.
As a black box that is just something that evaluates to a procedure,
Mm-hmm.
you'll note that the form of these 2 expressions is exactly the same.
The bit of the lambda 1 and the plus 2. Wait, of which 2
Exactly.
expressions?
Exactly. So
because
what does the plus evaluate to?
the procedure of addition.
That's right. So what does that lambda expression evaluate to?
The procedure of squaring something.
Right. So these two lines are like sort of exactly equivalent, except that it's two different procedures that get evaluated
Yeah.
to. But you see how they have exactly the same form.
Yeah, I'm just getting screwed up on the
This is actually kind of hard, and it's something that really shouldn't be hard, but is. And you kind of run into stuff like that in programming sometimes. Because all this really is just taking the rules we've talked about and applying them very, very literally. For some reason, this is very hard to do. I remember having difficulties with this myself, right?
what?
And everybody does, by the way, pretty much, right? So don't feel, you know, don't feel dumb or anything. Like
Well, I appreciate that.
almost everybody
I mean-
has trouble with this, right?
So, I mean, what I'm thinking is like if I start, going back up to the lambda line, where we asked it to evaluate, gave it the procedure of squaring inside of that, and then it asked to evaluate to the 6, but it kind of seems it was almost my temptation is to read left to right. So I've got that first open parentheses, and the one that's inside of that is a procedure that's inside of a black box that is then applied to the 6.
Well, let's think about it this way. So I want to introduce the idea of a form in Lisp and Scheme and whatever. And, this is one of the kind of things where I might even like define this a little bit incorrectly. It's something I have a very good informal notion of, but what I would say a form is, 6 is a form, okay? Mm-hmm. It is a single thing that can be evaluated kind of as a unit, essentially, right? A form can be evaluated. What's also true is when you open some parens, leaving aside some weird edge cases, when you open some parens and then you put a plus in there and then you have some other stuff in there, which could include opening and closing more parens in there, right? Then when you close that first paren, you have finished a form. That is a single unit, right?
Okay.
It can contain subunits.
Yeah.
Right? So if you do open paren plus 2 close paren, that whole thing is a form. That is a single form. Now, I would also call the plus sign a form and the 2 a form. I'm not sure if that's actually technically correct, but I'm not going to worry too much about it, right? It works that way. But look at this. We talked about this last time. You can do plus and then open a new parens and do times 3, 7, close the parens, and then new one times 6, 4. And then you're going to add those two products together, right?
Yeah.
So the multiplication is there where you open the paren, you have the times, you have the 2, the 7, you close the parens. That's a form too. But the whole thing is a form as well, right? Forms nest within forms.
Mm-hmm.
Okay.
Yep. Okay.
So if we're using these definitions, the plus sign is something that can be evaluated. It's a single form, right? This lambda expression, right? Yes, exactly, right? So you've got this top level form, which is the opening paren, the plus sign, da-da-da-da-da-da, and then you actually have 2 closed parens, right? Because you have to close both your parens. One is closing up, that second addition, and then one is closing this whole form that is the plus.
Yep.
Right?
Yep.
So when we look at that first lambda expression, right, where you just typed in just the lambda, not trying to apply it to anything, right?
Mm-hmm.
This is a lambda. This is what a lambda looks like. It is a single form. And you'll note that you have to close it with 2 parens, right? So let's really take a look at the syntax of this, right? So the way that lambda works, and again, this stuff's all just really literal. It's just a bunch of rules, right?
Mm-hmm.
Is that you have the word lambda, right? Which is much like a procedure. Lambda here, I believe, is a special form, but it is procedure-like, right? It is something you can put after an open paren and then give some arguments to, right?
Yeah.
Then we have another form. So that's really sort of the first thing in the whole lambda form is just the word lambda. We have another form, which is a set of parens, and there are going to be things inside those parens.
Mm-hmm.
And each of those things inside the parens, there's going to be symbols, right? Each of those symbols represents one argument to the function, and it is the name that the argument will be bound to within the body of the function, right?
Mm-hmm.
And then the body of the procedure. I keep using the word function here. That's a little sloppy, but And And then you actually have the body, right? And the body
Yeah.
is any form, right? The body doesn't have to be like something in parentheses. It usually is, right? But here the body, and so what happens is when the procedure is applied to arguments, what happens is the body of the procedure is evaluated with, any symbols in there are going to be replaced with those names that are inside it of any of the arguments bound to the arguments that got applied to, right? Does that make sense?
Um, uh,
So here, let's talk about it in this one here. And this is our procedure that squares things, right? It's not named square at this point. It's not bound to
yeah.
any name, but it is a procedure that squares things. So we've already said in this second part of it, right? The part that isn't the lambda, we said, okay, this takes one argument. And that argument in the body of the procedure is going to be bound to the symbol X.
Yeah.
Okay?
But it's not the X isn't the name
Of what?
of the procedure in the
No.
body of the,
It
X
is
times
not the
X.
name of the procedure. It is the name that the first argument to the procedure will be bound to.
Okay.
So you'll know what happens here. So, like when you do +2, right? There is a
Yeah.
body to this plus thing. We don't know what that body looks like, okay? Like how addition happens in Scheme is a little bit beyond the scope of what we want to talk about, okay?
Yeah. Okay.
And to be honest with you, addition in Scheme probably is not written in Scheme itself, right? I'll just tell you that. It is a primitive operation where it is actually calling out to your computer to do the work,
Mm-hmm.
right?
Yep.
But that too, let's just say it were written in Scheme, right? Somehow. We don't know what the code would look like. The two, it could have something that was like, it could call, let's just say that it was addition of either one or two numbers, and it was always those things. And it would have like the parameters X and Y, for instance, right? This is getting a little confusing. So I just kind of want to I want to really go back to this idea. So we talked about let before, right? That just
Yeah.
introduces a local binding for things.
Yeah.
So you can think of lambda as sort of doing this in a way it's very similar when you're applying the lambda. X is not the name of this. This procedure has no name. There is just no name for this procedure at this point.
Yeah.
Okay.
And it only can be applied on that line where you've typed it in with the lambda and said what X is in this context, right? Like
the only reason for that is you have no other way of referring to it. If you did bind it to a name, so
Yeah.
let's take one more step. And why don't you open some parens, type define, and then put that lambda expression, I'm sorry, first put the symbol square. That's what we're defining to be that lambda, right?
Hmm.
No, square.
Oh, what? This one?
Define square. And then a space, and then the lambda expression that we've been talking about, and then close up your parens.
That close that. Okay.
Yeah, there we go. Okay.
No.
Now, try applying square to 6. Right?
Okay. Yeah.
So let's talk about this, because this stuff's really, this is why I'm saying, the stuff about the use mention distinction, and then the stuff about being very literal about things is really, really important. And it's really kind of hard, and it's kind of weird that it is hard, to be perfectly honest with you. Because the only thing that could possibly make this hard is that you're not taking everything 100% literally, right?
Right.
If you take everything 100% literally, there's nothing hard about this.
Well, and it's tough. Feels like trying to basically unwind stuff that your brain is saying no, yeah, I know that. I put that together for you, or whatever.
That's exactly what's happening here, right? is that you are making some assumptions that we've never said and that do not hold, right? But you are jumping to these conclusions. And like I said, everybody does this. This stuff's really hard, actually. And this is actually what makes this hard. When we hear recursion, it's going to be exactly the same thing. I don't think we will this time. I think we had said last time we might, but we won't. But probably next time we will. Recursion is exactly the same thing. Because it's literally just about taking something literally. But it's like your brain almost doesn't want to. It wants to fill in gaps.
Yep.
You know, and so that's really what's going on here. So let's talk about the rules, first of all, right? So this probably makes it easier, right? Because this gives us something that's a little easier to talk about.
Yeah.
So what you have done is you have bound square to that lambda expression, right? And so now, what happens when you open a paren, type in square, and then, you know, type in 6?
Yeah. What happens? It's taking that procedure that now is signified bound to the symbols of the word square.
Right.
I mean, those 6 letters, you know, in that order.
Okay.
You know, which we've already said on the line above is this procedure that's, you know, that has been well, define is not the right word in that context, right? That has been
Well, square has been bound actually to the result of evaluating the lambda, right?
right. Okay, so that's
So when you evaluate the lambda, what does the lambda evaluate to?
the mathematical procedure of squaring something.
It is, right. It evaluates to a procedure. When we say define square to be this, we're defining square to be whatever the thing that follows it evaluates to, right? Which is that procedure. So let's note something. Square now evaluates to exactly the same thing that that lambda expression evaluates to, right? That's kind of what we've done. We've essentially said, let's make both these things. So it's really clear how you apply square to 6, right?
Yeah. As long as you know what it was that you did with the lambda.
But think about it this way. Square and that lambda expression both evaluate to the same thing. They're completely interchangeable, right?
Yeah.
You can use, you know, and so this is what I'm talking about. The literalness of this is the rule is you have this thing, you know, you have your open parens, you have something that comes after the open parens. That gets evaluated. Hopefully it evaluates to a procedure, right? And then you apply that procedure to the rest of the arguments within the parens till it closes, right? So you see now why this thing with these double parens here, right? The one above when we actually successfully applied like the lambda expression to the 6. You see why this worked now? What happened there?
Yeah, I think so. I mean, the first open parens is actually, you know, saying I want do this thing to 6. You know, so it's like
And what is this thing in that context?
It's the procedure that of squaring a thing that we laid out by this lambda expression or whatever it's called.
Exactly right. So, but let's really think very literally about this rule. Okay, we have an open paren. It says take the next form, evaluate it, and take what it evaluates to be a procedure that you then apply to the rest of the arguments. Right. So the lambda expression here, from the very opening parenthesis of it to the very closing parenthesis, right?
Yeah.
And note that there are 2 closing parentheses.
Well, yeah, because the first one is the body of the procedure. Is that what it's called?
The body of the procedure.
I mean, the first closed parentheses, the ones that's, you know, immediately after.
Body. Now, note that body does not necessarily, that body does not necessarily have to be something that begins with a paren, although it pretty much generally is, okay?
Yeah, well, right. You said that. I don't.
What we're doing is we are closing the multiplication. The body of that procedure is just a multiplication.
Yeah, x times x.
X times x. But we do have to close that multiplication. We have times xx. That's the body, right? Open parens times xx, this thing that does it. So we have to close that up, right? Because that's the body. But then the lambda expression as a whole needs to be closed too, because that's the last thing in the lambda expression. The lambda expression has 3 forms within it. It has the keyword lambda.
Yep.
It has the argument list. And then it has the body of the procedure.
So, uh, how is the argument? I don't quite. So the argument list in this is saying X. So X in this case is then 6. Like 6, you would take whatever. I'm somehow
Yeah.
missing something.
So this is really, really important, and this is a lot of what Lambda is there to do, is bind names to values. So let's think about it this way. We could write a procedure that always squared 6, right? Pretty easily, right?
Hmm.
You know,
Like when 6 comes up, you just
no, but
take
I mean a
it.
procedure that whenever you called it, it squared 6. Like,
Gotcha.
it
Yeah.
wouldn't be very useful though, because we already know the answer to that. It's 36, right?
Yeah.
We want a procedure that can be applied to any number, right?
Yeah. Yeah.
So that means when we're writing the body of the procedure, which is the thing that does the work, right? Somebody is going to have given us a number as an argument, right? Like if you look down here at square 6, or if you look at where we're applying the lambda expression directly to the 6, right? Until you do that, the procedure is defined before you know what is, what it's going to be applied to. You can later on apply anything, but we've got to write the body without knowing what the value is, right?
Yeah. The value of it when it's applied to whatever.
Right. It's going to be applied to a single argument, but we don't know what the value is, right?
Yeah.
But we have
The
to say
result.
multiply this thing. So we have to have a name for that value. Which it's not bound yet, right? It will be bound once you actually apply it to an argument. So what the argument list is saying, and this is the rule for the argument list, right? Is you see that there's one name there, so you know that this is a procedure that will be applied to exactly one argument. Okay. And it's saying the body of this procedure, which is what's actually going to be evaluated when we apply it to an argument, whatever argument this procedure is applied to, I want you to take that single argument and I want you to bind it to the name X within that body, right?
Okay.
Do you see what I'm saying?
Yeah, yeah. So that's the X. That's the argument part, and then uh, the body of the thing comes next. So it's saying, oh, but yeah, I don't know.
No,
I
I
think
mean
I'm still.
let's keep going with this until it becomes crystal clear because it's very, very important, right? It's okay if it's hard. We talked about this like at the beginning of all this, which is that some of this stuff is legitimately really difficult, right?
Yeah.
It's hard to wrap your head around. And I may not be doing the best job explaining it either, right? Like, let me see if I can find a better way of putting it, right? But again, let's talk about very literal rules here, right?
Mm-hmm.
So it seems really intuitively obvious. You call square 6, right? It squares 6, right?
Mm-hmm.
But what's actually happening there? So what's happening is this procedure has a body. And the body of this procedure, you can look at the lambda, the body of it is this thing, open parentheses, multiply x by x. What's x?
X is the argument that's going to be applied to whatever value.
Right? By the
You
time
end up-
you're actually evaluating the procedure by applying it to an argument, it is bound. That name is bound when the body actually gets evaluated. But here's the deal with this lambda. What it's really saying is when this lambda is applied to arguments, evaluate the body of the lambda, just that third form. Just evaluate that. Evaluate times xx. Oh, but wait, what's x, right? And that's what this argument list is for. It's to bind this argument name to this name. X
Okay.
inside the body. So
Gotcha.
you can think about it like this. You can think about it as if there's this rule when we apply this lambda to it, which is replace the entire lambda expression with times xx, and then replace each x with 6 if you apply that to 6.
Which is, or whatever you put in.
Whatever you put in.
Yeah.
So is that making a little bit more sense?
I think so. Yeah. I mean, I guess what I'm wondering, like, and maybe this will just become more apparent as we do more of them, but I mean, it doesn't have to be X there. And
No, it doesn't. So here, let's try a different thing. We tried lambda of x. You know, you wrote out that lambda expression and
Yep.
you applied it to 6, right? Can you do that again? Just actually write out the lambda, apply the lambda longhand, right? Don't use square. Use the actual lambda notation.
Yeah. So the one that was up here.
Yep.
But don't just copy it in.
Yeah, I mean, just literally do exactly the same thing here. Just so we're clear. Just so we're going on with this. So you have to close the lambda first.
Yeah. Which is what I just did there. Yeah. And that one.
Okay. Now, try doing that again, but every place there's an X in that line, replace it with a Y. Ooh.
Did I miss something? Oh, that helps when I actually spell the lambda.
Ah, yes, there is a B in lambda. Sorry, my vision, as I said, my vision is not perfect.
Yeah, I'll have to figure out how to use this.
I mean, it's partially just, it's pretty late and I've been up for a very long time. So it gets particularly blurry at this time of the evening. Yeah.
Okay.
So this works here because we don't care what, you know what I'm saying? We don't care what this argument is named. But it has to be consistent. Try doing that, but replace the Y only in the body. Right?
It's gonna.
So leave an X in the argument list, but then write Y in the body.
Make any sense.
So this is going to blow up. What's Y?
Cannot undefined, cannot reference an identifier before its definition.
Right. It's just Y isn't bound to anything, right? So the purpose of the argument list is to tell you how many arguments you need, right? But the main thing here is that within the body of the procedure, which is what's going to get executed, right? We just want a way of generalizing this idea of multiplying one number by another, right?
Yeah.
We want to generalize this idea. We want to write something in terms of a number that we do not know the value of yet. Because when we write the procedure, we don't know what you're going to apply it to. You could apply it to many, many different things. And what makes it useful is the fact that it can be applied to many, many different things.
Yeah.
Right? It is an abstraction over the process of multiplying. And, we're giving this process a name. But the thing is, we have to say, well, multiply some number by itself.
Mm-hmm.
Well, I just said some number. That's a way of referring to the argument. Another way of doing that is to say, well, we're going to call it X. So it's a little bit like in mathematical notation where you would say, okay, let X equal 6. What is X times X? And that's kind of what we're doing. That's what the argument list is for.
Well, I mean, it's got to be something, and I guess that's the language or whatever. I mean, that knows to apply the X. That X, that the number that then after all you close the parentheses.
Well,
yeah.
So there's a set of rules, right? And that's sort of what it is, and that's what we've been talking about. Is literally these are the rules.
Yeah. Okay.
So one of the rules is if you see an open parenthesis, the thing that comes after the open parenthesis is procedure, and then you take the rest of the things inside the parentheses. You apply the procedure to those things. So that's one rule, right, that we have. There's another rule, which is sort of what lambda does, right? And I mean, this in a way is actually like, do you remember we were talking briefly last week about, there's this concept called the Turing machine, which is this abstract concept that Alan Turing came up with, which in a sense defines computation, right? That's a big oversimplification in some ways, but I mean, it does define computation in a pretty broad way, actually, right? So it turns out that there's another formalism called the lambda calculus that a guy named not Alan, that's Alan Turing, that a guy named Alonzo Church came up with, called the lambda calculus. And that's where this lambda is coming from. And it also defines computation, actually, and is really completely equivalent to the Turing machine. right? Even though they're totally, totally different formalisms. And the reason for that is that computation itself seems to sort of be built into the structure of the universe in some way, right? And that's something for philosophers to worry about. We're not going to worry about that, right? But it does turn out that computation, you can define it in a number of ways and you get the same thing if you do, basically, is what it comes down to. So this is very much based on the lambda calculus, right? So it's not just scheme. It's just scheme happens to like be kind of as close to the lambda calculus pretty much as as it is closer to the lambda calculus than most languages are. Like it maps to it more closely.
Yeah.
But yes, there is this rule in scheme. And what the rule is the way that lambda works is there are three forms in a lambda, right? There's lambda, which just says, hey, this is a lambda, right?
Yeah.
There's a second form, which is an argument list. And that is a sequence of names. And the procedure will take that many arguments, right? And then the third thing is there is a body of the procedure. And when you apply the procedure to arguments, what happens is you evaluate the body of the procedure with any names inside that body that are in the argument list will be bound to the corresponding values that get passed as arguments, right?
Yeah. Yeah.
And that's literally the rule. It's just literally that's the rule. So what happens when you apply lambda of x times xx? What happens when you apply that to 6? Right? Because we know this is the rule for applying this to an argument, right? See the open paren, and then the lambda's expression, you apply what it evaluates to, which is a procedure, right? But what's happening here? Well, what we say is that this entire application of a procedure, this whole form from the open to the close, it applies this procedure to the 6. We say, okay, this procedure takes one argument and it binds it to x. And then what we do is we evaluate the body of the procedure with x, bound to that argument, right? So we're evaluating this times xx and we're binding the value 6 to the name x when we're doing that.
We're making that calculation.
Well, because we've said these are the rules, right?
Yeah.
The rule for the lambda is that it's a procedure, basically, that what the deal is the body gets evaluated. The body is what gets evaluated when you apply this lambda to an argument, right? So what happens is when you apply this lambda to an argument, what you do is you evaluate times xx.
Yep.
But because this x is the single thing in the argument list, we know that it's going to get applied to one argument. And when we evaluate this body, x will be bound to the name of it, right?
The x will be bound to the name of it?
I'm sorry. I'm sorry, I'm misspeaking. X will be bound to the value of the argument that gets passed in, right?
Yeah, got it.
Right. So something we did last week, which I actually realized, I was looking back over. You remember I mentioned a book called SICP to you?
Yeah.
We'll take a look at SICP at some point because SICP is a really good book. And we'll look at some of the stuff. The thing is, SICP is kind of hard. Like, let me put it this way. SICP jumps in actually quite a lot faster than we're jumping in. SICP is not an easy book for people with no background to pick up and just look at, right? Like, part of what we're doing in a way is building up the background that we can look at SICP.
Yeah, sure.
Even though it does start completely from the beginning, there's a sense in which it does not assume any knowledge, but it also does not explain things too. Yeah, it explains them very clearly and very literally, and it expects you to follow that, right?
Yeah.
It's not necessarily an easy book to pick up directly. I'll say that I already had studied, I was out of school by the time I read SICP. And there were parts of it that I found fairly difficult, actually, at that time, right? I'd been programming for years. I was a professional programmer. It's a great book, though. But one of the things I realized is actually last time we did sum of squares, and I didn't really know. I just kind of picked that out of the air. I realized it's actually a very early example from SICP, partially because they go on to use it in some more stuff. And it's just, especially because I was showing Dave some stuff from SICP last year, I think it stuck in my head as a good early example. So I unknowingly actually cribbed that from SICP. Not that I feel much shame in cribbing from SICP because, right, the only reason I don't tell you, hey, go read SICP instead of talking to me on the stream is because SICP is hard, right?
Yeah.
Like, I don't think I'm going to do a better job, but I think I may do a job that is easier to understand, if that makes sense.
Sure. Yeah.
But anyway, Sum of squares. So you follow what I mean by sum of squares, right?
I mean, just no more than taking two squares and adding them together. I mean,
Well, taking two arguments, squaring each of them, and then returning the sum of those squares.
okay.
If we're being precise about it. Can you write that procedure? Can you write it out as a lambda?
Never, it's like can't figure out how many parentheses ahead of time, but
Well, we're just writing the lambda here. We're not applying it, right?
Okay.
So you only need the one paren, right? Let's talk about why there's two parens when you apply the lambda.
Gotcha. Yeah, the first one was open it for be able to put the 6 in there.
Well, it's really because of that rule that says take the next thing and to apply it to some arguments. Because what we want to do when you have the double parens is take the lambda and apply it to the 6, right?
Yeah, yeah. So we're trying to do a sum of squares, which is going to be
So how many arguments is this going to take?
going to be 3, wouldn't it? You got to square one thing. Well, no, because you can. Yeah, I would think it would be 3. You're gonna.
Okay, why are there 3?
Because you got to square one value, square another one, and then you have to do the value, and then you have to add them together. So it seems like there's 3 different steps.
There are 3 steps, I guess, but there are actually only 2. So, I mean, let's really think about what this procedure does. It takes 2 values, squares each of them, sums the 2 results, and returns that result, that sum, right?
Mm-hmm.
So there's only actually 2 things that vary. If I want to, you can think about here, and actually I think SICP calls this wishful thinking. Like, let me put it this way. Let's say that we had a procedure and we had named it sum of squares already. What would it look like to call it? What would you want it to look like, right? I want to get the sum of the squares of like 7 and 8, right? How would you want it to look when you called it?
How would I want it to look when I called it? You'd want to just put in those 2 numbers. I see what you mean. You'd like put in whatever.
You want to write sum of squares, 7, 8, right? Close your parens, right? That's what you'd want it to look like. I mean, that's sort of the simplest thing. I want the sum of the squares of 7 and 8, right?
Mm-hmm.
So, like, how would I want to use something? Like, if I could wave a magic wand and have this procedure written for me, what would it look like? This is actually no, seriously, this is actually how you program a lot of the time.
Okay.
You're like, I want something that does something. Like, if I could wave a magic wand and have a function that did what I want. This is actually a really important point. I know it may seem a little weird, but it's like, that's a lot of the time how you program. You're like, well, what would it look like? Okay, that's the signature of my function. Mm-hmm.
We're not trying to define it right now. We're just doing lambda. Right? Was the other one how do we define? Yeah.
Well, we are trying to define it. We are defining the procedure. We're not trying to apply the procedure to anything. We're just trying to define it. But we are defining the procedure.
Or we're not
okay. We're not going to use define to bind it to a name. You are correct.
Yeah, that's okay.
Yeah. All right. Sorry, I misunderstood you there. That's a little bit of like ambiguity in that term define.
Right. Okay. So let's see here. 2x and y time. Like the maybe it would be.
Okay. So hang on a second. Let's go back to lambda. Again, this is this is about very literal rule following, right? Uh-huh. So we've decided how many arguments are there to this function?
2.
What does the argument list do? What does it contain?
Arguments.
It does. Why is there a plus sign in there? Are we binding plus to anything?
Well, we want to like add the 2 things together.
But the work that we're going to do is all going to happen in the body of the function, in the body of the procedure. Okay. So any addition, etc. What the argument list is for is to just list what the arguments to the function are and say what names we're going to use to refer to them in the body. That's all that the argument list does.
So there's going to be.
But okay. except the argument list is a single form. Okay. So it's an open paren. So in this case, it would be an open paren, an X, and a Y, right? They're all in the same parens. There's no, yes,
Oh, how does it know those are
space.
two?
Because of the space between them.
Got it.
Okay.
Okay.
And we'll talk a little bit about lists in a little while, right? And that might make some of that a little clearer. But we haven't talked about lists yet, and we don't really need to. So,
I'm missing something. Hold on a second. Then I would do this part. Got those two, and then that one. And then one more.
yep. It's okay. Try hitting return and see what happens. Does it blow up? You get a procedure. Now, that doesn't guarantee you that the procedure does what you want, but it does tell you that you didn't do anything syntactically terribly wrong, right? Because there was no error. So how would you go about testing this to see if that lambda actually does what you want?
I would put the exact same thing in and put a new and put a argument in it.
How many arguments? How many arguments?
Oh yeah, we need an X and a Y.
We do.
Yeah. So I would do something like yeah.
Okay. That's not quite right in terms of your parens, right? Because you need to close the lambda before you give it any arguments, right? The lambda has to close. The arguments don't go inside the lambda, right?
Yeah, but isn't this the closing?
So you see how it's highlighting things, right?
Yeah.
See how you have that, right? That tells you what parens you're closing, right? And that's really important to sort of be aware of, because trying to actually count parens is a terrible way to deal with things.
Yeah, seriously, I'm like, what the hell? Okay, so I should.
Yeah, it can be a little hard at the REPL sometimes with parens. One thing you can do to help with this sometimes is use new lines. We'll talk about that a little more at some point. But anyway, so let's see what happens if you do this.
Should be 61.
Yes. So yes, you got it right.
Nice.
So, is this making it a little clearer what's going on?
Yeah. Yeah, I think I'm starting to figure it out a bit. Right.
And so the argument list is just one list of arguments, right? It's not, it's a single form, right? It's not like X in parens, Y in parens. That would be, a variable number of forms. It's a single form, so you open the parens, and then it's just this. And so,
And signified by spaces, it means you could have a list of arguments that had all different symbols, stuff, as long as there weren't any repeating, or maybe you could even, maybe I'm getting ahead.
It would be important not to repeat something in the argument list. I imagine you would get an error if you did that. Try writing sum of squares, but make it be like y, and then times y, times y, right? Just do that again, right? And make the argument list y, right? You're going to get an error here.
Sure.
We should see what it does. You're also probably going to want to, well, hang on. Now you have x's that don't refer to anything. So you might want to say times y as well in the body, right? Well, no. Keep doing what you're doing, right? This is the error we want. But in the body, you still have x's. Right? So replace those with y's too. Because it doesn't make sense to have x's there anymore, right?
It's
not going to be bound to anything, right? Yeah. And hit return there. And yes, this is exactly right what we expect to see. Duplicate argument. That doesn't make any sense, right?
Oh, and it's highlighted that second y.
Yes.
So
it's telling you.
Yeah, if I took that y away and closed that parentheses up after the first y, then it would just be, adding it twice. It's square twice.
That's true. That would be a slightly weird way of doing that, but it would work. Now, I do want to point something out to you about what you did, which is fine. It works. But I just want to point it out, which is that when you wrote out the lambda, you said plus times XX times YY, right? You
Mm-hmm.
do already have a square procedure. So you could, for instance, because you already have a square procedure, although I guess it's not defined up top, but like you could have
Yep.
used square x and square y instead of times xx and times y, right? Do you see that that
Yeah.
would have been exactly the same?
Yep. Yep.
Okay.
Because we define square up there underneath 23.
So we do want to keep some of this stuff. Now, I do want to talk now because I really wanted to make it very, very clear that it is lambdas that are creating these procedures, right? I want the
Mm-hmm.
lambda part of it to just be very upfront because otherwise
Yep.
people get scared of lambda, right? They think, oh, lambda, it's a weird name, it's whatever. I really do think it's better to introduce people to lambda first. SICP does it in the other order, though. They actually show you, usually when you are defining a function that you want to bind to a name, you do not use lambda to do it. There is a shorthand for it with define, okay?
Gotcha.
So let's try writing, why don't you copy the define with the lambda for square, define square lambda, whatever, up into the top part, because we're going to want to hang on to this to refer to it later, right? Yeah. And then, but let's write another one below it, which is define square 2, okay? And here what you can do is, so put in the argument list for square. So just an X here, right, in an argument list. I'm pretty sure this is how this works. It's been so long since I've written scheme, but I'm pretty sure it just works this way, right? And now just like times XX, and then close up all your parens.
In a parens times XX.
Just,
Yeah.
right, take the body from the lambda above and just include the body here, right? Put the body
Yeah.
in here. And then you're going to have to just close up all your parens as usual, right? So, all right, try copying this down into the REPL because I don't want you to hit run yet because if you hit run, you will lose everything that's at the REPL and I don't want to lose everything at the REPL yet. Okay.
Yeah.
And you may get a warning here, but try copying that and putting it down into the REPL. It's probably going to give you a warning about like the upper thing being out of date. Don't worry about that. Okay. So try doing that. Hang on a second here. Oh, right. Yeah, that's what I was saying. I don't write scheme all that much.
Identifier.
Hang on one second. Okay, yes, that is what you do. So, right, move the name square 2 inside the argument list, right? Just move it in like before the X. So the first thing is the define form. The second thing is one form that is like square 2 and X, the name of the procedure and and then the arguments.
Sorry, I wasn't listening there. The first thing is
This
what?
is fine. Just put a square 2 into those parens, but before the X, right?
Before the X, okay.
Before the X. And yeah, you want to get rid of any extra spaces. Yeah. Okay, so try copying that into the REPL now. All right, and try applying square 2 to something. Just, see it work. It's good to see things work. Hang on. Did you put it in parens? No, you didn't. How do you apply functions to arguments? Procedures to arguments? Yeah, okay. So we see that this does work. So this is really exactly equivalent to the form where we defined square to be this lambda, but note that there is a subtle difference in the syntax here, right? When we define just a symbol to be another thing, there's no parens around the symbol name, right? It's just the symbol name. When we defined pig to be 42, it's define. It's the symbol that we want to bind to a value, right? And then it's the value we want to bind it to. However, right, and that's exactly what we did when we defined the square and then we bound it to the value of the lambda, right? We're taking the symbol
Yeah.
and we're defining it to like,
Square.
what that lambda evaluates to, which is that procedure, right?
Yeah.
But note that the syntax for this is slightly different. It's a shorthand. And what it is, okay, if instead of just giving you a symbol name, I give you some parens, and inside those parens, I give you a name and then some argument names. It's equivalent to the lambda. It's saying, so make me a procedure, and then it's got the following arguments, right? So it's saying, make me a procedure named square 2, right? That
Where
takes
X.
x as an argument, and then this is the body of it. Is that clear?
I think so. So, but you'd square, but it just seems weird because I mean, maybe this is after what we've been doing. The square 2 is the name or whatever, and then the argument is after. The square 2 is not an argument in that thing. It doesn't seem like
It's not. It's not. Square 2 is the name. So the first thing when you
use define.
use define with this special syntax, right? Then
Yeah.
what it is so define is the first thing inside the define, right? Defines the first form.
Yep.
The second form is a list that is the first thing in the list is the name of the procedure, and then everything else is an argument, right?
Okay.
So it's as if it's the argument list that it would be if it were a lambda, but with the procedure name added to the very beginning of it.
Yep. Yep.
So tell you what, why don't you define sum of squares in the top panel? You don't need to do it too, but define sum of squares using this define syntax. And by the way that you would normally like name something like sum of squares in Scheme is to put a minus sign between each of the words.
Okay.
That's not true in most programming languages, and that will actually blow up in many programming languages. But in Scheme, that's the standard way of doing it. Yeah.
Um, oh, wait. Whoops. I mean, it must. I guess it's. I don't have to count up the parentheses because it's highlighting it for me. What's those lines it's doing though? Do I have a?
It does not actually like what's going on. Why don't you? I'm having a hard time reading what's
Well,
going
maybe
on.
maybe it's because
Oh,
I.
no. Okay. I think it may
Yeah.
actually be. No, it's actually helping you out. It's trying to be helpful.
Yeah.
It's showing you. So where you have like the X's, it's showing you where the binding for that name is coming from.
I got it right.
It's saying
Okay.
this is where it's getting bound.
Yep.
Right.
Yep. Makes sense. All right. Let's see how this goes. Whoops. I won't do it that way.
I find that a little annoying, to be perfectly honest with you, but it's okay. So, yeah, you could type it in right now. For instance, do this. Yeah, and try calling it with something.
I got to put out this whole thing now.
You mean type the whole name?
Yeah.
Yeah. I mean, depending on the editor you use, some editors will give you code completion, meaning that if there's like a name like that defined somewhere, right? It'll sort of fill it in for you, But like, yeah, typing is definitely part of programming.
No. I mean, I feel like if I was using it a lot, I mean, I guess sum of squares is nice because it's what it is. It's like easy to remember because that's what it's doing, but
there are a great number of arguments, I guess, between programmers about abbreviating things, right?
yeah.
And so at a certain point, things can get kind of ridiculous. But my general inclination is to lean away from abbreviation. And the
Hmm.
reason is that then you have to guess what, like you have to remember, how'd I abbreviate it? Now,
Yeah.
there are some abbreviations though that are so common and like so conventional, in certain programming languages that they're fine, right? Like in C, for instance, in C-like languages, index is something that is used a lot. You basically have index as a loop variable, and that won't mean anything to you at the moment, but it's used so often, and there's a convention of just like abbreviate that to I. That's just I, right?
Yeah.
And there are other things like that, things that is just so common that you do tend to abbreviate them, and that's the convention. But other than that, I don't like to abbreviate very much because I can never remember how I abbreviated things. And then you get stuff where like two different people working on the same code base will wind up accidentally abbreviating things differently in different places, right?
That would be a problem. Yeah.
It is. I mean, you just have to remember, okay, so in this function name, it's abbreviated this way, but in this other function name, it's abbreviated that way. But it's inconsistent. And now you have to remember that all the time, and you get it wrong because you switch it in your head. So you have to look it up every time you want to call one of those functions, right?
Right.
It just
Yeah.
turns into a real pain a lot of the time. So I would rather type a little bit more or, set up my editor to do code completion, right? So that it does most of the typing for me with these long names. Where it can start to be a problem is when your line lengths start getting super long because you're trying to like cram several very long names onto the same line and you have to like be breaking lines in places you wouldn't want to. And so it can become a problem at a certain point.
Got it. Right.
But generally speaking, yeah, I would lean more toward writing things out than abbreviating them is my general
I mean, do
prejudice.
you find that you get? I mean, I know we're sidetracking,
Sure.
but like you get like a long line like that, and then you're like, well, maybe this is isolated enough here, or whatever. Again, whatever the calculation be, I should abbreviate this and just like find and replace that kind of thing. And
That's pretty
pretty.
rare, actually. That's pretty rare. Typically, we find other ways of dealing with it,
Hmm.
which there are some, right?
That's good. We don't have to.
Yeah, yeah. But I mean, it depends. Sometimes you will decide to rename something. Yeah. I mean, sometimes it's just not a very good name, you know? But it could
Yep.
also be because you could be like, okay, this name is too long. Let me think of something shorter. Hopefully, that
Hmm.
isn't an abbreviation, though. Maybe there is like legitimately there is a shorter name that means the same thing.
Got it.
It can be tricky if you do this across a whole code base, though, that a lot of people work on. If they are used to things being named one thing and it's something
Yeah.
that's all across the code base and you rename it out from under them, and suddenly they're like trying to type this thing that used to be there and it's not there. And they have to remember, oh, we renamed this. Now, sometimes you should do that, absolutely. Sometimes if something is badly named, actually naming things well is actually so incredibly important. Like,
Yeah, I couldn't imagine. Yeah,
yeah, an
and
awful
it's
lot.
hard to predict sometimes.
It is sometimes. Sometimes you realize we named this wrong, and then you have
Yeah.
to do something about it. The
Huh.
thing about it is too is that, and this isn't clear to people a lot of the time when they start programming, especially because when you start programming, the mechanics of it are fairly difficult, and you're like, okay, so like this is the hard part is getting the mechanics of this right,
Yeah.
right, and like some of the mechanics, I mean, some things remain really hard about programming. Some of the mechanics really become pretty second nature, though, right? A lot of the stuff that seems hard at the beginning, you've been doing it for 20 years, or to be honest with you, even for a year or two professionally, right? A lot of this stuff starts to become, much more straightforward. Writing code that you can easily understand, though, right, and that
Mm.
other people can easily understand is really really important. It is a big part of writing decent code, and
Mhm.
there are a number of aspects to that. One of them is like, gosh, writing code that is as simple as it can be, that is not excessively complex, is
Mhm.
much harder than you might think and much more important than you might think. It's one of, I think, the hallmarks of good programmers is that they write simpler code, right?
Yeah.
Because there's some irreducible complexity, they call it sometimes, to problems, right? There are certain things that just have complexity to them. But there are ways of writing code that. So, first of all, there's a lot of ways of making things that are not irreducibly complex, pretty complex anyway. And it's quite annoying when sometimes people really over engineer things. They add complexity because they think they're going to need some stuff later on or whatever. And like they build up this whole thing and you kind of go look at the code and you're like, this really could have been expressed in a much, much simpler way.
Mm.
And some of the stuff that I've been dealing with this week, some of the code I've been writing, Like, I don't know. I don't actually want to name names here because I don't want to call anybody out. But
Uh,
it is an API that is like insanely over-engineered that I have no choice but to use. It's a third-party API, and I'm really unhappy about it. Like, the level of complexity to this API is so ridiculously out of line with what we're trying to do. And part of the reason for that is that what's being done under the hood here with this API really is really complex in many respects. But what they didn't do is figure out how to give it a simple interface. And so that's something you can do as a programmer, right? Which you can say, look, I have this stuff that really is complex under the hood, in the guts of it, right?
yeah.
But I'm going to design things in such a way so that you can use it with a simple interface, right?
Yeah.
I'm going to put an interface between you and the complexity so that you don't have to think about the complexity when you use this code that I'm
Right,
writing
that's what
about.
we were talking about at the beginning the last time. It's like it's kind of like it's inside the box, and you know what it's going to do, and you don't have to worry about actually having to make it happen every time or whatever.
Right. And this is this thing where, in fact, like, they just expose all of the complexity and the guts of their implementation and stuff, which is bad for a number of reasons. It also means that if they ever decide to change their implementation, the code that you use to call it is almost certainly going to have to change too. So if they change their mind about things in the future, my code is probably going to stop working. They're going to have to, they're going to release a new interface. Instead of having a single interface that's like, well, this is what the interface to this should be. And then you've got some complexity of like how that thing is done. And so we really do
Yeah.
want to talk about hiding implementations a lot of the time,
Yeah.
right? And remember what we said before about like the plus sign here, plus 3, 4, right? That's just how you want it to work. It's just, I mean, it's a very simple example, right? But that's like, how does plus actually add things up? And we don't know, and we don't have to know, thank God,
hmm
right?
hmm
We just know that it does, right?
I still have my fingers, but I don't really try not to use them. Just,
Yeah. See, your computer does not have fingers. So we can probably rule that out. However, it could be that it connects by internet to a farm of people who are paid to sit there and add things on their fingers. We can't be sure that that isn't how it works. Although if it works that way, it does it very quickly. They are nimble.
yeah, right. Or there's a hell of a lot of them.
Or there's that. Well, I mean, I don't know if there's the kind of thing where you can break. I mean, let me put it this way: adding 2 and 3 on your fingers. I feel like you can't do that any faster with 100 people than you can with one person. There's no way to break that up between 100 people, right? Some stuff you can.
Ask it out.
like this is pretty limited. Like there's only 5 fingers involved here. So I feel like there could be no more than 5 people involved. All right, so that digression aside, but it really is true. Like, and a lot of what we're going to be talking about, actually, eventually, if we, assuming we keep doing this for a while, is about how to actually write code that we can understand. I mean, it's something you get better at over time. It's something that I certainly did not kind of always understand the importance of, and I'll admit something, right? Which is that when I was a very young programmer, and I wasn't even all that young at the time because like I started programming kind of late. But when I was pretty new to it, I was sort of proud of how much I could hold in my head, right? Because I will say that at one point in my life, I was very good at holding a lot of things in my head simultaneously, right? Better than I am now, that's for sure. But I was also like half the age that I am now. I also had a lot of practice doing it because all the code I wrote required that you do it, right? Because I was kind of proud of it. So maybe not all the code, but I would write code where like you had to keep a lot in your head to follow the code, right? And I was sort of proud of it. I was like, not very many people could write this code, which I guess in a literal sense was probably true, right? But this didn't make it good code. You had to keep a lot in your head. And I remember one thing in particular. I was working on this project as computer graphics, right? And I was making triangle strips out of points. Like, I don't want to get bogged down in the details of that, right? But like, there was this very sort of complicated indexing into the stuff that I was doing with these like big algebraic expressions that I was just kind of like writing out like da da da. And I managed to kind of like, boy, and it was really hard to keep track of all of it, but I managed to keep track of all of it, and I like did it, and it worked and everything. And then like a couple months later, it turned out there was a very subtle bug in it in some edge case. Didn't come up very much, but when it came up, it was bad, and I had to go back to that code and figure out why that bug was there and fix it, right? And so it isn't just that I'd written code that like would be very hard for somebody else to understand. I had written code that I couldn't understand without a great deal of work. I had to go through all of that thing of like getting it all back in my head. And it's actually quite a bit harder when you're reading your own code than it is when you were writing it in the first place, right?
Yeah, because you got to get right. You got to get back into the mindset you were in, or not the mindset, but like the
Yeah, you got to get all those little details back.
when
So
you're
yeah, it's
laying it.
really that stuff's really super super important.
Yep.
And you burn your fingers a little bit. Speaking of fingers, right? You do a little bit too much of this stuff. You like write a little bit too much that's too difficult. Let me just make sure this is not very important email because I am sort of on support duty a little bit. Why am I not seeing? It says I have email. All right. I'm not going to worry about it right this instant. Raf is probably watching email too, etc. Hopefully that's not an urgent support request. It is 10 p.m. We do not, technically speaking, guarantee support at this time of day, but I do like to get back to people when I can, as quickly as I can. So okay. That digression aside, I think I need a drink of water because I am
Okay.
actually rather parched. So
Yeah.
why don't I'll grab a drink of water? Why don't we take like just a minute or two break, unless you want longer?
Nope, I'm good.
Okay, I'll be back in
Yeah.
one moment. I just need a little water. All right. Okay, I'm back and I have water. So you're there still, right?
Yeah, I'm still here. I was just trying this out with um, using roots instead of squares.
Okay.
I better pick something that's.
I'm not quite sure this does what you think it's going to do, but okay. What is x over x? Always.
Uh,
So you just wrote a function that I'm pretty sure always returns the same thing. So I just point that out.
a,
What is x over x?
a one.
It's
Right?
1. What's y over y?
One.
Does it
Yes,
matter
it's
what
all.
x is or what y is? No.
Yeah.
So I'm pretty sure that function always returns 2. But go ahead and give it a try.
Right.
How about sum of square roots, though? Right? Is that kind of what you're trying to do? Like sum of the square root? Sum of the square roots?
Yeah.
Okay. Let me just make sure that this is what I believe it is in Racket. But, because again, I don't do Racket very much. Yes. Square root is just SQRT and it is built in.
Oh, yeah, gotcha. So,
Yeah, why don't you try it out with some number, like square root of 4 or something?
oh, you're saying
Yeah,
I
just give
can.
square root a try, just to see how it works, right? Get a feel for it, the fact that it's there.
Yeah. Okay.
Boom.
Cool.
Okay.
So then I should be able to do. Uh, no, this is what I need. Oops. Whoops.
So this isn't quite right. You were really close up above, right?
Yeah.
But look at how the form of what you're doing here is different. So first of all, it's a sum, right? So what does that imply you would want to have in it if it's a sum?
Yeah. Whoops. So then
And then, by the way, I'll explain to you what actually happened there and why you got a 3. Why what you did was legal and why you got a 3.
okay.
Okay. So let's talk really briefly about why what you defined in the first place was actually legal, even though it had more forms than what we've looked at before, and why you got a 3 as the result. So, one kind of idiosyncrasy of this syntax is that here, why don't you take that? Do you remember print line? Do you remember when we looked very briefly at print line?
The REPL part of print, like,
So print is something the REPL does. We can print something ourselves if we want to. So if you type in like an open paren and then print ln, so speaking of abbreviations, it's actually all one word. Whoops, all one word.
okay.
And then hit a space, and then double quotes, hello, and double quotes end parens, right? It prints something. Note how the color of that is different than everything else that we've been seeing, okay? And here's the reason. We aren't printing anything in these things that we're evaluating above, right? The P part of the REPL process is printing it, right? That's the REPL. It's evaluating it and it's printing the result of what it evaluated.
Yep.
This is a subtle distinction, but when we do print line, what print line evaluates to is nothing, okay? So we don't see anything get printed that it evaluated to. But when we call print line itself, when we call print line, we are ourselves printing something. And so the REPL colors it differently to kind of tell us, hey, this isn't my output, this is output you printed. Okay.
Okay. So you could do something that's totally nonsensical or whatever that it doesn't care. It's just returning you what you asked it to.
It's actually not returning you anything. It returns nothing. Print line returns absolutely nothing.
Okay. So by return, there has to be evaluation going on.
Yeah, print line does get evaluated. It's just the rule for evaluating print line is that it returns. I mean, it's actually kind of a little bit of a complicated thing. Like the difference between like a value that represents nothing and the absence of a value is a kind of subtle distinction. What we are seeing here is the absence of a value. There's also, by the way, a value that represents nothing. We're not seeing that. Okay.
Yeah. Yep.
Did that make sense? I know we'll talk about that one eventually, but like, does that make sense to you that there's a difference between a value that represents nothing and an absence of a value?
Yep. Yep.
Okay. We're seeing the absence of a value here. In fact, I mean, I don't know. I don't want to get too sidetracked, but we'll just show you real quick something. So type in just values inside parens. That is what we saw. That is the absence of a value. Now, type in values space 3, right? That same thing with the with inside the parens, right? Inside the parens. Do the same thing except apply values to 3. Hey, look. Now, do values 3, 4. Or 2, 4. It doesn't really matter what they are.
Right.
Ah, okay. Which is something we haven't seen before. Everything, I think, pretty much that we've evaluated so far, we've just seen one thing. So values basically creates values. It's kind of what it does. But values applied to no arguments, it's the absence of a value. Now, if you type in single quote, open paren, close paren, okay. Well, actually, try typing in null. Try typing in null. I'm pretty sure. Again, I get my Lisps confused as to which one's which. Yes. So null, and this is a value that represents nothing rather than being the absence of a value. And null is one way of writing it. And quote, open paren, close paren is another way of writing it. What that is an empty list, by the way.
Mm-hmm.
That thing above. And an empty list in here is considered to be the same thing as null, which is considered to be a value that represents nothing. The empty list and nothing are synonymous. That's a little weird semantically, but we'll live with it, right? However, I'm pretty sure... we won't get into that. We haven't talked about true and false yet. And true and false are important, and we will talk about them. Let's see, what time is it? Yeah, we have half an hour. We might talk about them tonight. So... But let's keep going, though, kind of with what we were doing. What did we want to do? Ah, yes, the prints. So, if you take that line where you had sum of square roots, the one that evaluated to 3 when you gave it 4, 9, that one, right? Copy it down. Don't hit return, though, right? We're going to edit it. But just put it on the line of the REPL to do it. Okay, so name this like printing square root, okay, or something like that, right? Just change the name, not the define, but the name of the procedure. Just, we don't want to overwrite sum of square roots, but like printing square root or something. Okay, but is there a minus sign in there?
Whoops, no, sorry.
So this there can't be spaces here, because remember that's, that's what's telling it where the name ends and where the arguments start.
Yeah, makes sense.
Okay. So put print line hello in place of that square root x. Okay. And yeah.
Got to have the double parentheses around it?
Double parentheses around it. That's right. Yeah. And now you can go to the end of the line and hit return, right? Yeah. And now try calling that function. Apply it to, say, 2 arguments, because it takes 2 arguments, x and y. We're not using the x, but it probably shouldn't take 2 arguments, but...
But what kind of arguments? I mean,
it pass it the same thing that you passed it before, right? What did you pass it? Like something at 9, right?
Okay.
Okay. So this is what's happening here. Is that I said before that like this defined that the last thing in it. I'm pretty sure this is also true with the lambda too. I'd have to check. Said that the last thing in it is a body, right? Well, it turns out that it can actually, right, which is a single form. It turns out you can put more than one form there, okay? The rule is that it evaluates each of the forms. If there's a sequence of forms, and you can put as many of them in there as you want to, right? As many forms as you want to. It evaluates all of the forms, but it throws away their return values until you get to the last value. And then it returns that value. Right? So the only way this is useful is if you don't care about the return values. And the only reason that that's true is because you were doing something, you remember we talked about side effects?
Yeah.
Okay. Printing is a side effect. Right? How do we know it's a side effect? It doesn't return a value. We're not evaluating it for the value that it returns. We're evaluating it because evaluating print line something changes the world. And how it changes the world is it prints some stuff to your screen. Right?
Okay.
Adding 3 and 4 together doesn't change the world at all. Now, the REPL does change the world. The REPL has side effects, but it's just like that thing I was talking about how the colors are different here with the, that's telling you who's causing the side effect to happen, right? If it's that blue, the REPL may be causing side effects, but your code is, well, I mean, it could be, but like, that's not what's the printing, that particular side effect is not there. So you don't actually do this very much, this thing with the multi things, unless you want to do several things in a row that have some effect on the world, right? Is that sort of clear?
A little bit. I mean, I understand that, like, when I tried to square root up here and properly wrote this, that it threw out the, this square root x piece, and it just did, as an overall function defined as sum of square roots, so that when I told it to sum of square roots, it just ignored the first value, which corresponded to x, and the second one, which corresponded to 9. That's what it worked on.
So this is what I was saying before is that when you have these multiple expressions here in a row, kind of as the body of the function, it evaluates all of them, but it only returns the value of the last one.
Okay.
Right, because you're not combining these two values. You have the square root of x. Okay, you have the square root of y. You're not defining a way to combine them. So what does it return? It doesn't know what to do with both of these things, but it can return the thing from the last one. So it's taking the square root of x. It's saying, okay, but he's not asking me to do anything with it. So I'm just going to toss it away. And now I'm going to take the square root of y. And okay, this is the last thing. So I had better return the value that I got, which is the square root of y, right? Which turned out to be 3 because you had, 9 was the second argument when you called it. Okay. So we modified it down here a little bit. I mean, there's no reason for it to take 2 arguments now. X is not being used. So we could have taken X out of the argument list, right? And then you wouldn't have had to do 4, 9. But what we did here is we're showing that this is getting evaluated, this first form here, right? We know this print line hello thing is getting evaluated because we're seeing it print.
Well, what happens when I have to... This.
Still needs 2 arguments because we defined it that way. Right? But, so take that sum of square roots thing. Let's try a couple different things, right? First, take it and instead of doing print line hello, have it do print line x. While we still have an x. And then we'll get rid of the x. Nope, not the string x. The symbol x. So if you print the string x, you will get an x. But you give it the actual symbol x. Printline knows how to take a number and turn it into a string to print it, right?
Okay.
It's just going to print whatever x evaluates to.
Gotcha.
And now try calling it with 4 and 9. So you see what happened here? Does this make sense?
Yeah, it's printing. It's printing. It's when I ask it on the printing square roots of, it just prints the x, and then but it's actually square rooting the y.
Right. It's returning the value of the last expression. But note that it doesn't. It can throw away the return value of print line x. We already saw the return value of print line is nothing, right? It is just the absence of a value at all. Print line just doesn't return a value, right? Print line does something, which is print something to your screen. It causes a side effect. Right? So typically when you have these bodies, multi-line bodies, it's always everything except the last expression is something that you only care about the side effects from, right?
Okay. Yep.
Because it's throwing all that away, and that's the only time you ever really do this. And because like we're going to be writing a lot of code that's very disciplined in how it uses side effects. This isn't something we're going to want to do a lot of. And I'll say that I obviously do have to write some code. I live in the real world where I do write code where I kind of, do a few things in a row for their side effects. But it is this thing where I'm very disciplined about that. And what that means will become clearer as we go along. And I actually think it's something that makes for better code, to be very careful with side effects. I should say that right from the outset, which is that pure expressions that just like evaluate to something and don't change the world in any other way, in any way.
Yep.
They just like evaluate some values. They don't change anything, are far, far safer than things that change the world. Things that change the world. And you can't do without them, right? Because we're passing off the responsibility to change the world to the REPL when it's showing us what these things are doing. But when we call square of 7, right? We're not doing it for our health. We want to get the number 42, right? So that number 42 has to be reported to us somehow. And the way that it's being reported is that the REPL happens to be printing it. We're not, but the REPL is, right? That's a side effect. So writing a computer program that has no side effects, do you see why that's a useless thing to do?
Because it would just be.
It has no way of even telling you what the answer is, right? To tell you what the answer is, it has to print it out. Do you see what I'm saying? That's a side effect. So, as somebody once said, the only thing a program that has no side effects can do is like heat up your room, right? Because it makes your computer work a little harder. If you know what I'm saying? I'm going to say even that's a side effect though. So you could even say it's, in a weird kind of philosophical way, you could say it's almost impossible to write a program without side effects if it actually calculates anything. Of course, if you have a smart enough compiler, it'll just compile your entire program away once it realizes that it has no side effects, and then it won't even heat up your room. And that, you don't have to worry about what that means. But that's a little bit of a joke. Right. The thing about side effects, though, is we want to be very disciplined about how we use side effects. Side effects are dangerous. The order in which you do things with side effects matters quite a lot, for instance. And if you have something that has side effects, doing it twice is really different than doing it once. Right? And sometimes. And so you have to be very careful with side effects.
Cool.
Yeah. So I think we should probably move on a little. We talked about these things. We talked about let. Do you remember let?
Yeah, kind of.
Okay.
Trying to remember how we applied it. Let. Yeah, I can't remember exactly.
Okay, yeah. So the syntax of it, you're not going to remember, and this is why probably we're going to want to build you a little crib sheet of things at some point to refer to. This is kind of why I wanted to have that file from last time, but it's okay. We're just kind of making it again. This is almost like a little crib sheet here that we're building.
Or I'll just grab it and copy it over.
So, well, we're kind of rebuilding it. So. Let me just make sure I have the syntax of let correct. Yeah. So let is actually a special form. So, if you do an open paren let, and then let's say open, like 2 more open parens, x space 7 close paren, space y space 8 close paren, and then close up that whole thing that you're in, and then just have a body here. This should be pretty simple, pretty similar to what we've done before. Put in a body that adds x and y. And close up all your parens and hit return. Okay. So you see that this is, there should be some similarities here. Some of this should look a little bit familiar to you, actually, right?
Yeah.
So we're not defining a procedure here. We're just evaluating a body with some values bound to some names, right?
So basically, the first open parentheses after the let defines, what we're letting, what we're identifying these symbols as
Yeah.
equaling, and then there's a body where we're asking it to
Yeah.
evaluate it.
Again, there are three top level forms in let, right? Just as there are in like lambda. And they're actually very similar, right? The let corresponds to the lambda, right?
Mhm.
Then we have something that's very similar to the argument list. It's like it is a list of names to be bound. The
Mhm.
difference between this and the lambda is the lambda puts off binding the values. The let binds the values right there, right?
Yeah. Okay.
And so it needs to have a little bit more structure, right? The lambda can have this argument list that is just the names that you want bound. Here, we need to give it a set of pairs, basically. We have to give it a set of like name and the value that it should have, and then another one that's name and the value that it should have. But otherwise, the structure of it is really the same thing as a lambda's argument list, right?
Mhm. Mhm.
And then the last thing is a body, just like a lambda has a body. And I will let you in on a little secret. And we said actually we might talk about this time. One way of writing let, if you need to implement let in a system, and this may
Mhm.
very well be how Racket does it. It is certainly how some Lisp systems actually implement let, is that you actually can implement let. So there is a way using Lisps of having code that writes code, right? Code that takes code and transforms it into other code in a lot of cases.
Mhm.
And this is one way of implementing special forms. And so, kind of what I'm talking about is probably a little bit hard to follow everything that I said there. And I don't necessarily want to delve too deeply into it. But you can actually make let. So, everything this let is doing, you could do with lambdas, right? Let's talk about this a little bit actually, because this is a kind of good thing to note. Let's write a
Mhm.
simpler let. Why don't you write a let where you bind x to something and then add 3 to that thing? And you can bind x to whatever you want, right? Okay. Almost not quite. Can I just point out you still need the extra parens?
Because I'm going to have the body.
It's just the syntax of let, right? So up above, right? So you want to
Oh,
close. Yeah, yeah. Do you see how up above it's like you have some parens and then you have some things in parens inside those parens? Same thing here. It's just you've only got one of them, so it's kind of
yeah,
superfluous.
yeah, I got you. It was closing let behind the Y8 there. You got the first close Y8 and then
Yeah, well,
close
you're
let.
not closing the let, but you're closing the binding list, right? It's not an argument list, but it's a binding list. Yeah.
Oh, I'm not closing that. Yeah.
Yeah. So there you go.
No. Closing that.
Yep. This looks correct to me. Try hit and return.
Why does, when I'm going back to that, let,
Right. You don't want to close the let until the end. The let is the top level form that we're
yeah.
doing. Okay. And the body needs to be inside the let. Here's the thing. These bindings that we are establishing where x equals 4, they
Mm-hmm.
only exist inside the let. If you type x now and hit return, you get error. It's not bound, right?
Okay.
That binding only exists within the body of the let. Just
Mm-hmm.
like when you're calling a lambda, right? When you call, I mean, we talked about this last time, but let's talk about it again because it's important. When you call square, right? Like
Yeah.
it binds some values to the name x while evaluating its body. But those bindings go away as soon as it's done evaluating the procedure, right?
Yeah.
Right?
Yeah.
Which is really important. You don't want some name x hanging out, right?
Yeah.
You don't want some name x hanging out that like calling some procedure changes the value of that thing, right? That
Mm-hmm.
anything else can see. Like calling the procedure should not cause changes in the world. That's what we were talking about before, right? Like that would be a side effect. That would be something outside the function. It'd be changing something that was visible outside of it, and that would actually be pretty icky if that happened, right? So the let is the same way. The let is binding a value to this name X, but only for as long as it takes for it to evaluate its body. That body is still part of the let. The let has three parts, just like the lambda did. It's got the let to tell you that it's a let. It's
Yep.
got the binding list, which corresponds to the argument list. And then it's got the body that gets evaluated with the names bound to the values, right?
Yep.
Okay, same thing here.
Hung up though on like why is the double parentheses?
Why the double parens? Okay. So look at the one up above where we have an X and a Y, right?
Yep.
So what we're saying here is we have a list. Let's note that parens make lists. We haven't talked about lists yet, but these are basically lists, right?
Okay. Yep.
So we have a list of binding pairs. And each binding pair is defined as two things within parens. So a binding pair is something like X and 8, right? Or
Okay.
Y and, or yeah, X and 7, or Y and 8. That's a single binding pair, those things in parens. But we have a list of them, so we need another set of parens to contain them, right? And that's kind of
Yeah.
clear in this first let, right?
What's that?
That's kind of clear in this first let where you've got two of them. It's kind of clear why you would want it to be that way,
Sure.
right? Okay. So it still works that way even if you've only got one pair, right?
Okay.
One binding pair. It's still a list of binding pairs. It's just a list of binding pairs with one binding pair in it. But that does mean that the parens double up.
All right.
Does that
All
make
right.
sense?
Well, not completely, but I'm not.
Okay. So
Just
this has to do with this literalness that we're talking about. Now, you could define the language such that it didn't work that way. So that if you only
Yeah.
had one binding pair, you got rid of the extra parens. You could do that, right?
Yeah.
There are kind of good reasons not to, though. There are reasons that you want things to be very consistent, that you want them to
Yeah.
always work the same way. One of those reasons is what I was talking about before, is when you're writing code that writes code, right? It's actually a lot easier if you don't have to like special case it, right? Does this work differently if I have, we won't talk
Yeah.
too much about that right now, but consistency really is pretty valuable.
Yeah.
And
I agree with that.
this is consistent. It's like, how does let work? It always works the same way. It's
And you
got,
could have as many pairs as you want, that are like, but yeah, so it's the outside. Yeah, I see it now. It's the outside parentheses, even in the X4 example where there's only one pair. It's the outside that are saying this is the list, and then it's the X and 4 of pairs, and then the X and 4 is its own little pair
is its own
within
little
that.
pair, right?
Yeah, I got it.
So it's always got the same syntax. It's just, you do wind up with these doubled up parens, which are a little bit weird, but, and I will say this, not every Lisp has the same syntax for let. I do think that eventually we'll want to actually play with Clojure. Clojure is a Lisp. Clojure, in some ways, has pretty similar syntax to Scheme. Clojure has let. Clojure's let has a different number of parentheses than Scheme's does. So, and it can be like, this is why every once in a while I'm saying, oh, let me
Sure.
type something. I make sure, because I actually I have programmed at this point in several Lisps in my life, right? And there are some things that they just kind of differ a little bit about, or a lot about. Like I wrote a lot of Common Lisp at one point. Common Lisp is actually there are some things about Common Lisp that are very different actually from Scheme. And I have a tendency to sometimes drop into Common Lisp and Scheme, and it doesn't go well. Things blow up. And I have to be like, oh, yes, right, Scheme. Right? Because I don't actually write a huge amount of Scheme. It's a great pedagogical language. And I don't think in principle there's any reason that it couldn't be a great language for writing serious commercial programs, but it is not used very much for that purpose, right?
Yeah.
So, I mean, part of it is Scheme itself is a very small language. Now, Racket is a big implementation. Racket has a whole bunch of stuff, most of which I don't know, because I haven't done much Racket, that fills in the things that are missing in Scheme. You probably don't want to take a bare bones Scheme implementation and try to write commercial software with it, because you'd just be missing a huge amount of stuff, right?
Yeah.
Racket tends to have a lot of that stuff, though. I think you could probably write commercial software in Racket, but I haven't really assessed it seriously to know if I would want to, right? But again, it just isn't something that's done that much. Whereas Clojure, it's not a language like JavaScript that's used by like hundreds of thousands of programmers, right? But Clojure is used like for serious commercial work. Like, quite a few Fortune 500 companies have significant systems written in Clojure. It's a nice little language. So I'm not even sure I'd call it a little language. It's a nice language. So I don't want to belittle it there, actually. I like Clojure. But yeah, so we have this let. Now, what I did kind of want to point out here, and again, I'd want to point out to you something about this, which is some of this stuff that I'm showing you is in some ways like, I don't think some of this stuff is usually considered kind of beginner stuff.
Hmm.
Some of this is a little bit advanced in some ways. And
Hmm.
I think it's really good stuff to get in your head early on, though, right? But it's pretty conceptual. So I just want to be clear, like, if some of this stuff is difficult, like, you should not feel bad about that. Some of this stuff is legitimately stuff that you wouldn't normally probably show to somebody at this point. I happen to think it's not a bad idea, as long as you're able to like be like, okay, this is hard, right?
Yeah.
You know,
Um, it's gonna shut
because I'm
that one
gonna
up above.
I'm gonna
See.
ask you something here, which is, can you rewrite that let? And I will give you some guidance about this. Can you rewrite that let in terms of a lambda?
Yeah, let's think about this for a second here. What are we trying to do? We're trying to create a.
And I will give you plenty of help with this because this is kind of like expecting you to actually get the answer to this at this point is probably expecting a lot. But let's see. Let's give it at least a little thought. It might. It's good to get the wheels turning.
Mhm. Um, procedure. A little bit. Um, I have a hard time, like really kind of. I mean, I can make a stab at it, but I don't really know why I'm doing it. And I'll be like, well, maybe this would work.
Okay, let's go with this now. Let's see what happens. And I can give you some hints that will amend it probably into what you want. So we'll see.
Um, hmm. Well, I guess I'm coming up with the.
So I'll give you one hint. In the lambda, you can't specify what x is bound to, right? That's kind of the point of procedures.
Hmm.
The binding will come from it being applied.
Yep. Okay. Yeah, that was what I was initially thinking. Uh,
That's very much correct. Yep. I mean, you're basically you're very close with what you're doing. Everything you've typed so far is correct. You're missing perhaps one thing. Well, but remember, okay, now you're maybe going a little astray because we're talking about this second let here with your where you're just like adding three to x, right?
oh, okay. I was looking at the one above it.
You could do the one above it too. You would need to put the y in the same argument list though. You would need to take both x and y as arguments.
Okay. Right.
Okay. So you could do that as well. If you want to do the one above, that's also fine. You could do that. But the y has to go into the argument list too.
Which would be a double parens.
No, this is not the binding list, right? This is just a lambda. So you can refer back to how lambdas work. We did have a lambda above with an x and a y. Although I guess we no longer have that one. We did at one point write a lambda that represented sum of squares though. Yeah, that's correct. Yes.
Um, and then it would be the same thing, wouldn't it? It'd be
It would be the same body. Okay. Yeah, it's very much the idea. So if you close that up and just hit return, for instance, you get a procedure. But so here's the trick, and this is what I was kind of getting at. Take that lambda
Mm-hmm.
and apply it to the values that you had put into the binding list, which is the 7
Yeah.
and the 8.
Whoops.
Right. You're probably going to need, remember, you want to actually apply this lambda to some arguments. So how do you apply a lambda to arguments?
Yeah, I'm gonna need another.
You don't actually. You don't need these parens.
Oh, I don't need those ones there. I need this one over
You
here.
need that one at the beginning. But you don't need any around the 7 and the 8, remember? Because this is just our rule for like, how do we apply a function? How do we apply a procedure to arguments, right? Exactly. And now if you do this, yeah, you need to close all your parens.
Oh, I see. Yeah, I've clipped one more out there.
All right, so what did we get here? We have lambda of xy plus m. Oh, yeah, okay. So this is just incorrect parenthesization. Pretty sure. So you need to close the lambda before you start giving it arguments. Do you see that?
Right. Yep. Let's see. Yeah. There we go.
There you go. And
Yep.
so you never strictly need lets, right? You can always essentially use a lambda to achieve what a let does. And in fact, in many, many Lisp systems, let actually gets turned into lambdas under the hood anyway, right? It's not the only way that you could handle this in a Lisp system, but it is very common to actually do it that way. And I can't tell you what Racket does, whether or not it is actually expanding this into lambdas. So this is kind of why I started with lambda, and then we kind of went on to like just define and stuff, and now we're doing let and stuff. Is that what I want to make clear is this binding of names to values is first of all incredibly important, and it's the kind of thing that like everybody kind of sees this to one degree or another when they start programming, pretty much regardless of the language. Like if you start doing Python, you probably don't go into it in the depth and the detail that we have, right? You kind of take it for granted, and I think it's really easy to miss how important this binding of names and values is, how critical it is. And so getting a really good, like, fundamental understanding of this at the beginning makes a lot of things clearer later on. So that's why we're kind of going into, like, in a way, kind of really crazy depth over this one little thing, which is how do we bind names.
Yep.
So
Cool. We got to wrap up
we
here.
got to wrap up here. Okay. It's 10:26. All right. Well, okay. We went back over some stuff. I think we're going to want to probably kind of, it was mostly recap tonight, actually. We were kind of like recapping. But I think it's really good because some of this stuff is just like, you kind of do have to go over it a few times before it sticks.
Absolutely. And I think that it will be good to have a little crib or keep cheat sheet and for me to actually take a look at it a couple times through the week too, because it fades away, and I'll be able to build that in as part of my routine a little bit more as we go along. It's just a little bit tough right now, but
sure, it's the holidays among other things. I've been a little busy too. One of the things that I've been kind of wanting to do is to make some short videos that just go over this stuff in a very condensed format and upload them, right? Just like boom, 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 boom. And if I do that, like I think I'll try to get on that and actually do that. And I think you can refer to them as basically kind of a review of stuff. Like, okay,
that'd be cool.
this is just this stuff really fast. I think it helps to go through it though and actually type the stuff in, make the mistakes, like let the wheels turn in your head. It's something I've kind of learned about learning things, which is that it's actually, like it's the mistakes that teach you things. And you know what? I have learned so much from my mistakes, Amos, that I've resolved to make a lot more mistakes.
Is that what's going on?
I'm going to start making mistakes constantly. I think what I'm going to do is try to do absolutely everything wrong now, because that way I just learn a lot. Tomorrow I'm going to try playing in traffic. See what I learn. See what I learned from that one.
Yeah, well, that is part of the problem there. There does have to be an application of the learned.
Oh, there definitely is an application. Don't play in traffic, but sometimes the lesson comes too late. That's all.
Yeah.
No, this is the story of my life.
Yeah.
playing in traffic. I shouldn't have called this the mapping reduction. I should have called it playing in traffic. Anyway, yeah, so yeah, I'll see if I can find some time to do that. I have a fair bit going on right at the moment. Like,
Yeah. I mean, I may not look at it, right? You
you
know,
may not
this
look at
may
it.
not be the week. There,
Yeah,
the week will come. It just may not be
the
this
week
one.
will come. Yeah, it's all right. Like, we're starting off slow. That's fine.
Yep.
You know, like,
Yep.
we'll pick up some speed. We'll get into some stuff that's actually pretty. I mean, I think this stuff is actually really, really interesting. It
Oh, that's
feels kind
cool.
of basic. It turns out there's real subtleties to this. And I think a lot of people could look at this and be like, well, I mean, oh my gosh, you should really like not cover it in this depth or anything, but like look at this stuff in 15 minutes and then move on to interesting stuff.
Right.
I'm not
Yeah.
so sure about that though. I think when you really pin these fundamentals down early on, rather than worrying immediately about how to like make something appear on a web page, right?
Mhm.
I think in the long run, it really pays off, right? It makes learning everything else a lot easier, right?
Yeah. No, it'd be interesting to use just some of the basic uh, functions, and try them out with some of the different stuff it can do, whether in division or square roots or and see.
Yeah, I think we should like so we'll look at recursion pretty soon. We want to look at lists first and we'll look at recursion and like lists and recursion, just like our view of them could take another couple sessions.
Mhm.
However, after that, we could look at some of the stuff. They do some really neat stuff in SICP. They have some examples that are, I think, great examples, actually. It's just they're not easy examples to jump into, and they are kind of the first examples they give of some of this stuff, right?
Yeah.
So, but like once we have looked at it and it's a little bit under the belt, we can take a look at it. And some of them are really good examples, and they also use what are called higher order functions. And I'll let you go in a second. Oh, before I do though, the most important thing here is let's save this file, okay?
Yeah.
And why don't you save it to that directory that you made named code, and let's make sure you know how to do that.
Right. Okay, which I don't.
Okay, there's
We want to save all this mess down below. I mean, it's not a mess, but it's got a lot of
no, don't worry about
errors.
the REPL. Don't worry about the REPL. You know what? Yeah, you should at least save what's in the top though. At least save what's in
Yeah.
the top.
I put that lat thing up there because that seemed like that was a
Yeah.
good one to have.
That is a good one to have as an example, right?
Uh,
Um,
and actually, let me do the
and you can even
lambda.
put that last lambda that's equivalent to the let in there as well. Just so it's kind of like, okay, right, this lambda matches this let, right?
Cool.
Now, let's see. You're on a Mac. It's a little bit different. How do you do this? You may need to like unmaximize racket so that you can see the top menu. Yeah, there you go. There's a file menu there, right?
Oh, whoops. Yeah, okay. So I just do it how I normally would do it. I don't know. I thought there was a way of like saving it.
There might
but
be
yeah,
a
that would-
keyboard shortcut like Command S might do it as well. But
Save definition. What did I do? Oh, I don't think I came out of that.
I think save definitions is what you want. Definitions is basically, it kind of means save definitions as probably. It'll probably prompt you if you.
Yeah.
So it's calling the top panel definitions and it's calling the REPL interactions, I think.
Got it.
So
No. Okay.
you probably don't want to do it in documents though. Right? We made that thing in your home directory. I don't know. Macs sometimes irritate me a little.
Right.
So this is the file name. But do you see where it says that where? Yeah. Does it not give you a way to actually like navigate there? Go to Amos, right? So I would select Amos. That's your home directory, right?
Oh, it won't let me do it.
Should do it. I mean, there's enough lag here that it's pretty hard for me to. All right.
Yeah,
You know what?
no, now I can't.
We'll figure this out next time. Save it to documents for now. That'll go to your documents that it's in your home directory. It would be nice to actually have it go to code. I don't know why it's giving you like this this particular like I don't know.
Yeah, it's weird that it's not.
Okay.
Cool.
But yeah, I was going to say one thing, just sort of a sneak peek at something we'll be looking at, right? We've seen how you can pass numbers to functions, right? To procedures. And it should be no surprise that
Mm-hmm.
you can pass strings to procedures, for instance. One thing that might surprise, and that they can return strings and return numbers, like pretty much the functions we've done have all like taken numbers of arguments and return numbers. One thing that may surprise you is that procedures can take procedures as arguments, and procedures can also
Mm.
return procedures as return values. And
Okay.
this
Yeah.
turns out to be important. You can actually have procedures that create new procedures, or you can have procedures that can be parameterized with procedures. And we'll talk about why that is important. But that is one of the things that also some of these examples that I'm talking about from SICP also use. And we call this higher order functions. Like that's typically the name
Mm-hmm.
we use for when this happens. So all right, that
Okay.
was very good. That was fun.
Yeah, man.
So are we
Definitely.
planning on doing this next week, or are you just gone next week? Can you refresh my memory?
No, I'm back.
You're back.
I'm just gone over the week. Yeah.
Okay, cool.
Yeah.
I keep
I'll
forgetting
be.
I have more than one stream, and I keep forgetting like who's like, no, we can't stream next week. I gotta like actually start organizing this better. But you can stream pretty much for the foreseeable future, right? You don't have like any
Yeah. I
planned
don't
weeks
see
off at
it.
this point. Okay.
No. Even when I do, I'll be somewhere. I'll have. Right. But I won't have this computer. That is kind of a bummer. I wonder if maybe I want to get a laptop at some point or something. But
Oh, you're taking a vacation at some point, right? Aren't you? You're traveling again this winter.
well, I mean, we're taking that trip, so
Yep.
yeah, that'll be.
That'll be a
We're
significant amount
taking
of
it.
time, right?
Uh, I'll figure it out.
Okay.
Oops.
Okay, cool. All right. Well, listen, I will let you go. Have a good weekend trip. Drive safe. And
Yeah.
yeah, I'll talk to you sometime next week.
Awesome. Yeah, sounds good. All right. Thanks.
All right. Thank you.
Catch you later.
Bye bye.